Ladies and gentlemen, and welcome to the third and conclusive day of this Global Space Conference on Climate Change, GLOC 2023. Before we dive into today's program, let me remind you once again that also today you will have the opportunity to ask your most urgent questions through the IAF app. Using the Slido system, you have all the information up here. Today we will continue to discuss and highlight other important aspects connected to understanding and battling climate change through the use of space-based services and applications. And the first session of this day is a highlight lecture focusing on how humans are changing Earth. And it is my great pleasure to welcome on stage our distinguished speaker, Dr. Catherine Calvin, Chief Scientist and Senior Climate Advisor at NASA. Let me briefly introduce you. As Chief Scientist, Dr. Calvin advises agency leadership on the agency's science programs and science-related strategic planning and investments. As Senior Climate Advisor, she provides insights, recommendations for the agency's climate-related science, technology, and infrastructure programs. Dr. Calvin, the floor is yours.
Thank you, and thank you for having me here to speak. So what I want to do today is talk a little bit about what we know about climate change on Earth, both using observations to show how we've gotten to where we are now, as well as using broader science to understand where we might go in the future and how we might respond to climate change. So just to start, one of the primary ways that NASA studies the Earth is through our fleet. We have more than 24 satellites and instruments in orbit, including several on the International Space Station, that are continually monitoring the planet. Most of these satellites are global in scope, so we can see not just where we live, but we can see anywhere around the world. And all of this information is publicly available, so people can look at what's happening in their communities. We've been observing the planet for decades, so we can see both the state of it today as well as how it's changed over time. We're able to see things like vegetation, changes in the mass of ice sheets, carbon dioxide, clouds and precipitation, and much more. We're also continuing to innovate and add to our observations. So this past December, we launched a satellite called SWOT, or Surface Water and Ocean Topography, that'll give us the first global survey of water running through rivers and lakes. And we use water as we grow crops and produce energy, and this satellite will give us more information about how much water we have and how that changes over time. It'll also provide more information about oceans and ocean circulation. We use oceans that absorb a lot of carbon and heat and have a really important role in climate change, and SWOT will improve our understanding of those. Many of these missions are NASA missions, but a lot of them are also done in partnership with other space agencies, either within other agencies in the US or other international space agencies. So just as an example, SWOT, the satellite I just mentioned, is in partnership with CNES, with contributions from the UK and Canadian Space Agency. And that international partnership is really important, both in innovation as well as in sharing what we do globally. So how is the planet changing? So I'm going to start just with temperatures and talking a little bit about climate change and what we know about this. This is an animation based on surface temperature observations, though if you look at a satellite record, you'll see similar trends for overlapping years. The animation starts in the late 1800s, and it's going to work its way through present day. And what we can see is the planet is warming. 2022 was tied for the 5th warmest on record, and collectively the last 9 years have been the warmest since modern record keeping began. Temperatures are about 1.1 degrees Celsius above the late 19th century average, but we're seeing more warming over land than over ocean, and more in higher latitudes than lower latitudes. It's not just temperatures that are changing. We're seeing other impacts and changes in the Earth system that affect people and ecosystems all around the world. And I'm going to provide some specific examples of that going forward in my talk. But I did just want to say, this is showing you past temperatures. We also know that with continued emissions, temperatures will continue to rise. So in the latest Intergovernmental Panel on Climate Change report, or IPCC report that came out in March, it stated that the best estimate of reaching 1.5 degrees Celsius is in the near term. It is important to note that an individual year exceeding 1.5 degrees does not mean that we've exceeded that warming level overall. But the IPCC says that by 2030, there's a 40 to 60% chance that any individual year will be above 1.5 degrees Celsius. So we're continuing to see this warming in the future. We know from science what's driving warming. Here we go. So this is an animation of carbon dioxide concentrations from the Orbital Carbon Observatory 2, a NASA satellite that observes global carbon dioxide emissions. And so what we know from science is that it's unequivocal that climate change is caused by human activity, principally greenhouse gas emissions. And so this is showing carbon dioxide concentrations. And if you look at this over time, what you'll see is carbon dioxide concentrations are rising. This is from a satellite record. If you look at the longer surface records, you'll see that change over time. And that is driving a lot of the warming that we're seeing now. If you watch this animation, I'll try to play it again, you'll also see a seasonal variation. So if you look at this, it's animating through months, you'll see lower carbon dioxide concentrations in northern hemisphere summer than in northern hemisphere winter. And that has to do with the way plants respond. So as plants grow, they're taking more carbon dioxide out. And by having a globally gridded data set on carbon dioxide, we can help scientists better understand the carbon cycle, and so understand the role of plants. So as we emit carbon dioxide through burning of fossil fuels or through land use change, some of that goes into the atmosphere, but some of it's absorbed by land and ocean. And having this globally gridded data set helps us understand those processes so we can better predict them in the future. We can also use a data set like this to understand emissions. So this is taking that satellite observations, which were in concentration, combining with other sources of data, and now we can look at emissions around the world by different countries. And so this is looking at annual emissions, or average annual emissions between 2015 and 2020 for fossil fuel carbon dioxide only, and the height of each bar is giving you a sense of the level of emissions. So you can see where those emissions are happening. This is just a one average snapshot, so annual emissions, but you can look at this kind of information over time and track progress in carbon dioxide emissions. And if you look at that, what you'll find is some countries have emissions that are continuing to rise, while some countries actually have emissions that are declining. Globally, emissions are still continuing to rise, and what we know from science is as long as carbon dioxide emissions are positive, warming from carbon dioxide will continue. Or put differently, if we want to limit warming, we need to reach net zero carbon dioxide. It is also possible to reduce warming by having net negative carbon dioxide. So taking more carbon out of the atmosphere than we put in, you could actually reduce temperatures again. But we can take this satellite information about carbon dioxide concentrations, combine it with other information sources, and give you an estimate of emissions around the world. Carbon dioxide is not the only greenhouse gas. So if you were around yesterday, there was a lot of conversation around methane. This particular animation is a visualization of methane concentrations. It is a modeled product, so it's from a model run out of the Goddard Space Flight Center. But what we know, so first of all, methane has contributed to warming up until now. So warming to date, about 0.8 degrees Celsius is from carbon dioxide, about 0.5 is attributed to methane. But methane is a very potent greenhouse gas. Depending on the time scale, so in 20 years, it's about 80 times as the warming potential of carbon dioxide. On 100 years, it's about 25 times. There are different sources of methane. So methane, a lot of the methane sources come from agriculture, things like livestock and rice paddies. There's also sources from energy production, so oil and gas or coal mines. And different countries have different sources. And so this animation is showing global methane around the world for a few-year time slot. So you can see where those sources are. The brighter red, the more methane. We can also look at methane superemitters. So this is an image of the Southwest US. It is from EMIT, an instrument that was installed on the International Space Station about a year ago. And EMIT was actually designed to study mineral dust. So mineral dust are these fine particles that are kicked up from things like desert and agriculture. And the color of the mineral dust will dictate whether it absorbs or reflects sunlight. And so EMIT was designed to give us more observations of that so that we better understand warming from mineral dust. But the science team at JPL realized that we can also look at methane from that. And so they have been able to put out these products that show us where there are methane superemitters. And by overlaying with other data sets, they can identify some of the sources of those methane plumes. And so it's a really interesting innovation in how we use an existing instrument to measure something different. So that was the greenhouse gases. So we know greenhouse gases are rising. They've driven the warming we see to date. We also know that how much more warming we experience in the future depends on future emissions. So now I want to talk a little bit about the impacts of the warming. So not just temperatures are rising. I said that there were other impacts on the Earth system. So let's give a little bit of an overview of what some of those impacts are. And I want to start with ice sheets. So this is an animation of Greenland and Antarctic ice mass. And what you'll see is the change in the mass of ice sheets over time. This is from a set of satellites, GRACE and GRACE Follow-On. They're in partnership with DLR and NASA, and they've been observing changes in ice sheet mass for more than 20 years. So we have more than 20 years of information on this. And so what we can see is the total change in ice mass, which is what you see in that line chart at the bottom. You can also see the spatial change. So those red areas are places where we're losing ice. There is some blue where we're gaining ice. And by being able to do this spatially explicit, we can better understand ice sheet dynamics and help scientists better understand the processes that lead to changes in mass of ice sheet and better predict that in the future. When we think about the future, ice sheets are one of these impacts that scientists call irreversible. So that means even if we were to bring warming down, we wouldn't be able to reverse the loss of ice sheet mass on centuries to millennia timescale. The changes in ice sheet mass have more to do with temperature through time than they do with current temperatures. So it is an irreversible loss. And they do have impacts. So one of the main changes that happen with ice sheet mass is sea level rise. So as ice sheets melt, that water runs into the ocean and increases the volume of water in the ocean. And with more water in the ocean, we see sea levels rise. We're also, with the increased heat on Earth, we're seeing changes in it's called thermal expansion, where the oceans are taking up more space. So we have more water in the ocean, and they take up more space. And that has led to changes in sea level. And so this graph on the top is showing you global mean sea level. The chart starts in in the early 90s, because that's when our satellites that measure this started. So we have about 30 years worth of information using satellite altimetry to look at total sea level. And we can combine that type of information showing you total sea level rise with the information from the ice sheet loss that I just mentioned from GRACE and get a better sense of the contributors to sea level rise. So you might say, well, what does global mean sea level of 100 millimeters rise mean? What does that mean for me? And I think that's a very common question. When you're actually thinking about these impacts, it's not global changes that people relate to. It's what's happening where I live. And it's not just what's happened until now, but it's also what might happen in the future and how can I use that information to plan. So NASA's sea level change team has provided information like that. So we have a tool. If you go into the web and look for NASA sea level rise, you'll find this. We have a tool that shows you a map of the world, and you can click on points along the coast, and it'll tell you how much sea level has risen in that particular location and what the contributions are from different factors, like ice sheet mass loss and thermal expansion, or what's called vertical land movement, where the land moves up or down. And so you can look at how much sea level has risen in your coastal area. We've also partnered with the Intergovernmental Panel on Climate Change to look at projections of sea level into the future. So in a very similar tool on the same website, you can click on that coastal city anywhere in the world, and it'll show you projections of sea level into the future. And that information is really important for planning. And what you'll see when you look at that, though, is how much more sea level we might experience depends on the scenario. So future warming depends on future emissions. Future sea level depends on future warming. So there's a variety of possible futures for sea level in that tool. So that was sea level. There's some other changes in the water cycle that matter for people and ecosystems around the world. And so this is an animation showing you extreme wet and extreme dry conditions around the world. This is also using GRACE data. So GRACE, the satellite that measured changes in massive ice sheet, can also measure changes in terrestrial water storage and use that to get a sense of where there are floods or droughts. And what this is showing you, the red are the dry conditions, the blue are the wet. If you look at the bottom right The total intensity, that is an index that's capturing the severity, extent, and duration of these extreme events. And what we're seeing is that with warming, we're seeing more of these extreme wet and extreme dry events. And what we know from science is that in the future, with future warming, we'll see more heavy precipitation events, and in some regions, more droughts. So GRACE isn't the only way that we can look at droughts. So first of all, when you think about droughts, it impacts lots of different processes and ecosystems around the world. It's a big impact on agriculture. So farmers need to know what are the soil conditions, how much water do their plants need, and floods and droughts can greatly influence their yields. Droughts also have an influence on wildfire. So fire weather depends on how hot, dry, and windy it is. And so you can see understanding water and droughts and heavy precipitation events are really important for understanding those. The animation on the left here is from a different satellite called SMAP that's showing us soil moisture. And so that's really important for farmers and for understanding fire to understand how dry is the soil where you are. We have other satellites that can provide other information that's relevant to agriculture and farmers. So Landsat can tell us about vegetation health. GRACE can also give us information about groundwater storage, and farmers use groundwater for irrigation. So understanding how that changes over time and what's available is really important for planning. We have developed a tool called OpenET that's designed to help farmers understand water and plan their water management on their fields. It's targeting the western US, but it's open, it's free data, but it's designed to help people understand water management so they can better plan. When do I need to irrigate? How much to irrigate? Based on the conditions where you are. So moving from to another extremes, hurricanes I want to talk about. This animation, I'm going to describe what it is at the beginning, and then I'll talk about hurricanes and climate more in general. This is an animation of the 2021 hurricane season in the Atlantic. There were a lot of storms that year. It was a very active hurricane year, and what the animation is showing you is precipitation as well as the storm tracks for it. And so they're just going to animate their way through, but what I want to talk about is how hurricanes are linked to climate. So what we know from observations is that we are seeing more strong storms. So a higher proportion of the storms we're seeing are strong storms due to climate. There's also some evidence of shifts in hurricane tracks. So hurricanes like warm water, and so as the water's warm, you may see some shifts in tracks more northward. There's some evidence of that. We also know from some of the physical science understanding is that we'll see more heavy precipitation in the storms we see. And as we look into the future with climate change, the expectation is that we'll see a higher proportion of category 3 through 5 hurricanes going forward because of climate change. And these have really devastating consequences on communities in terms of flooding, infrastructure, and even in some places a human toll on ecosystems and people. So moving from that, I want to continue on land, and this is the last of the impacts before I move towards what we can do. So land is really interesting in terms of climate in that it both influences climate, but it's also influenced by climate. This is an animation from Landsat. So Landsat is a series of satellites developed in partnership with between NASA and the US Geological Survey that show you land. And this is a false color image, but you can look at, from this, you can see where there are trees, where there's crops, where there's urban areas. We have more than 50 years of Landsat. So the first Landsat was in 1972, and so we have 50 years of this information. And this is showing you Las Vegas over 50 years, and what you can see is urban areas are expanding. If you look around the world, that's a general trend we see. Our cities are getting bigger. Some parts of the world, we're seeing things like declines in forest area. We're also seeing shrinking of lakes in parts of the world. Well, as the land surface changes, its reflectivity changes. So the amount of sunlight reflected, and that has influence on climate. Also, as the land use changes, we'll see differences in carbon storage. So trees store more carbon than bare ground. And if we're changing the land surface, we're changing the amount of carbon land is storing. And that has an impact on how much carbon remains in the atmosphere and how much more we warm. And Landsat can give us a lot of information about that. And since we have 50 years of global Landsat data, we can look at that anywhere in the world. This is just an example from Las Vegas, but we have data sets like this for all over. So that's how climate is, how much what climate is changing and how it's impacting us. The question I always get asked is, what can we do? So I want to talk a little bit about what NASA's doing for climate. So we are a science and technology agency. And so I've talked a little bit about science. I'll come back to science. But I want to talk about technology. One of the things we do is develop technologies that can help people mitigate and adapt to climate change. And the first one I'm going to talk about is actually aeronautics. So the first A in NASA is aeronautics. We have a team that works with the aviation industry and has for decades to reduce the amount of energy use and emissions associated with flying. So when you're in your next flight, probably later this week, if you look out at the end of the wing, you'll see the wing curves up. That reduces drag, which means less energy used and less emissions, and that comes from NASA research. And we're continuing to do that kind of research on aircraft design, on airport operations, and on new technologies to make flying more efficient. So just a couple more examples on airport operations. They're looking at how to more efficiently move aircraft around an airport, and some of those have mean us spending less time waiting on the tarmac, which means less time waiting on the tarmac, but also less energy used and less emissions. We're also working on developing an electric airplane, so new technologies that can make flying use less emissions. The aeronautics team doesn't just work in the mitigation space, they're also working to help us understand how to respond to some of the impacts that we're facing. So I didn't talk a lot about wildfire, but one of the areas that they're working in is in wildfire. We have centers out in California that are experiencing wildfire regularly and trying to think about how we can help. And so we've had a number of workshops with the fire communities to understand what are the challenges they're facing and how can NASA technology help. One of the things we've learned is that a lot of putting out fires, we do that from aircraft in parts of the US, but those aircraft can only fly in what's called visible flight conditions. They can only fly when they can see, which means they can't do these flights at night, and they can't do it when it's smoky. And so one of the things we're thinking about is, can we use our technology, like uncrewed aircraft systems, to help meet those needs? And the aeronautics team has been working with the earth science team to look at how can we better monitor, predict, and respond to wildfire. So how can we use the technology and what we know to help in response? It's not just aeronautics where we develop technologies. Living, working, and exploring space forces us to think about sustainability and how we use resources, and that has impacts that we can use here on Earth. So I'll just mention a few. The first is on crops. We grow crops in space. So we are living and working at the International Space Station, and the astronauts there grow crops. And some of the research we've done to grow crops on space is used here on Earth. So we've done research into LED lighting that's used in indoor agriculture facilities. We've done research on fertilizer that uses less fertilizer. It directs the nutrients to plant roots at the rates they can use it, which means less fertilizer needs and also less running into rivers and lakes. We're also we do a lot of prizes and challenges to spur innovation in the community. We have a deep space food challenge that's trying to incentivize people to think about how to produce food with lower inputs. The Canadian Space Agency is running a parallel challenge. For space exploration, that means bringing less with you. Here on Earth, that means using less. We have another challenge called Watts on the Moon that's looking at energy reliability and energy storage on the moon, but that also means some of those technologies could mean better energy reliability and energy storage here on Earth. So continuing to think about how our technologies that we use for space and space exploration can be used here on Earth. The last couple things I want to think about is how we make data more accessible and how we get the information we have out to people. So we know a lot about the planet. We've been studying it for decades. We are scientists, we are engineers, we are experts. There are people everywhere that are making decisions that are influenced by climate change. How do we help them? And so we have an open source science initiative at NASA. This is really broader than earth science, but it's important for earth science. 2023 is the year of open science, and this is about going beyond just making data publicly available. All of our data is publicly available, but we need to think about how to make it accessible and easier to use so people around the world have what they need when they need it. And some of that involves more trainings, moving data to the cloud, thinking about data formats, and just trying to increase participation in our science so that the science has broader reach. We have a specific effort focused on Earth and climate called the Earth Information Center. This was a concept announced by the administrator in late 2021, and it is opening this summer. And the Earth Information Center is really about helping people understand how climate and Earth system changes are impacting what's happening where they live and what they experience, as well as providing information to help them respond to those decisions. There are two parts of it. There's a physical space and a virtual space. And in the physical space, we'll be showing visualizations and telling stories about the Earth. And I don't know if anyone went to the science communication panel on Tuesday. They talked about the power of visualizations, and that's something that really resonates with us. We work with a lot of science communicators, and really using these visualizations to inspire, to inform, and to engage. So using the visualization to draw people in, let them know what we know about what's happening where they live, and then leave them with something that they can take home. And so the virtual space will be that take-home portion. So you can go to that, you can watch the stories, you can see what we have, but you can also access the tools and resources that actually inform decisions. And we are organizing this around topics. So I think in missions, if you give me an acronym, I can tell you what mission it is, who the partners were, how long it's flown. That's not the way the general public thinks. They think about, I am interested in agriculture. I am interested in sea level rise. And so we're organizing it around that. So all you need to know is I'm interested in agriculture, and we can tell you what data we have. We're working with our other federal partners to bring together other data and other resources, so it's not just NASA, but the full power of what we know. And that will be opening in June. So I will just end with, part of what we are doing is helping understand climate change and understand how the Earth system has changed. We are innovating both in terms of new understanding as well as in new technologies. And a big part of what we do is share everything we have with everyone around the world so that what we know can benefit all of humanity. And with that, I will turn it for, I think someone's going to help me with questions.
So we do have a couple of questions. The first one, how does NASA transfer these innovative technologies to private sector and other agencies for operational exploitation?
So we have a very active tech transfer program that works towards licensing the technologies so that people can use them. And there are actually NASA technologies everywhere you go. You just may not know it. So your cell phone camera comes from NASA technology. And we have, if you're interested in learning specific examples and more about how we do it, we have a magazine we put out every year called Spinoffs. It's on the web. But they also have a portal where you can look up if you want to know about different types of technologies and how that have gotten out into the community. But it's a very active area of effort, is making sure that we get that technology out.
And the last question, can we track the groundwater recharge pathways and potential disruptions as well as storage and soil moisture?
So we have different satellites that track different parts of that. So GRACE can give us, we can use GRACE to understand changes in groundwater. We can use SMAP, the one I showed, to look at soil moisture. We have GPM that can show us precipitation. And we have, different satellites talk about different aspects of the water cycle. And if you were there was a plenary yesterday where they went through the whole history of how we monitor the water cycle from space. So we can see different parts of that. And then we can use tools like models to bring that all together and to fill in the extra parts of that. Okay. All right. Well, thank you all very much. I think we have a panel coming up next, so I will.
Well, thank you very much, Dr. Calvin. This was really exciting to see these statistics. I mean, what can be more impressive? Before we jump into the next panel, we would like to ask you all to help us with one thing which we would like to include into our highlights video that will also kind of remain as a kind of visual legacy of this conference. I would like to ask Christian and his team to come up here on stage, and I would also ask my team to come up here on stage. And we need your help because we want to have a very nice video shot where we are all waving. So please, if our video team will take a nice shot of all of you, so make sure that you are in the picture. I'll tell you when to wave. Please come here a bit closer. So we see. Come up, come up, come up. Yeah, it will be waving in this on this side. Come. Don't be shy. So I'll give you the command when to start waving. Iди сюда. Sebastian, iди сюда.
We have 1 minute.
Yeah, we have some reserve time, yes. So. blunda. Slišel. So, 3, 2, 1. So please all wave. Another shot. Come up, come here. Thank you all for your help. Thank you. You'll see the result if you join us today at the closing ceremony, so please don't miss this. This will be interesting for you. Now we need to reconfigure the stage a bit. We need some more tables up here because we are moving into the next plenary. First plenary of today's, which is titled Planning for Future with a Changing Climate. Earth climate is changing, and this is a rather undeniable fact, as we know. Space, however, provides one of the best places to monitor these changes and alert about their effects. This panel will bring together leading scientists and science advisors from space agencies around the world to discuss the climate challenges of today, advancements in research and technology, and solutions to help people plan for the future in a changing climate. And to lead this discussion, it is my distinct pleasure to welcome the moderator of this session, Dr. Sarah Gallagher. She is the director of the Institute for Earth and Space Exploration at University of Western Ontario. Please.
Thank you so much. It is my pleasure to be here today. I'm very excited about this panel. I think it adds something to the program to have the perspectives of 4 scientists who are operating in 4 different institutions with 4 different mandates, and to share what they're thinking about. We just heard a beautiful overview from Dr. Kate Calvin, who is our first speaker, so I'd like to welcome her up onto the stage. So as you know, she's the chief scientist of NASA, and I think the presentation that she just gave us showed us how the holistic view of a scientist who's able to advise a space agency is really powerful in bringing together all of the different threads of the impacts of climate change and how we can actually monitor them and integrate them into a coherent plan. The next next panelist we have is Dr. Prakash Chauhan, who is the director of the National Remote Sensing Center from the Indian Space Research Organization. Welcome to the panel.
Thank you.
And our third panelist is Dr. Rune Flobergagen, who's the head of Science, Applications, and Climate Department from the Directorate of Earth Observations from the European Space Agency. Welcome. And our fourth panelist is Dr. John Moores, who is the science advisor to the President of the Canadian Space Agency. Welcome onto the stage. So in order to get the perspective and understand the context in which these different scientists are operating, I'd like to give them each an opportunity to describe their role in their organization, and also to talk about the real priorities of the organizations they're working on. So Kate, why don't we start with you?
Yeah, so you guys all just heard a little bit about my agency. So I am the NASA's Chief Scientist and Senior Climate Advisor. My role is an advisory role. So I provide input into both internal to the organization, up to the agency leadership, about our climate portfolio. And again, for us, climate is science, it's technology, it's also our own operations. And so thinking about how to connect that. And then I also do a lot of communicating that externally with partners and the public.
Thank you. Prakash, how is your role in your organization, and how does your mandate? What's that like?
Thank you, Sarah. Thank you. Good morning to you all. First of all, thank you, IAF, for giving this opportunity. I come from Indian Space Research Organization, and I lead a center called National Remote Sensing Center, which is located in Hyderabad in India, which is the prime center of ISRO, which is basically developing all ground segment-based operations for all Earth observation satellites of ISRO. So currently we operate around 23 ISRO as well as international satellites including data reception, data processing, data dissemination, archival, and most importantly, the applications of Earth observation data for socio-economic development. So I am currently in the role of director. I'm spearheading almost all these activities. And as far as the climate initiatives are concerned, we are dealing with almost 60 ministries of federal government of India and around 29 states in India in terms of providing geospatial services for governance as well as issues related to climate action for Himalayan glaciers, Indian coastline, fragile ecosystems, and forestry, forest fires, and many such things. That's all. Thank you.
Thank you. And Runa, how could you please describe your role and the nature of your mandate for your organization?
Yeah, thank you, thank you. My role at ESA is to lead basically all the activities that we do in the area of earth science, climate, application services development, essentially. Probably, well, not everybody in the room probably knows that the Earth observation programs at ESA are all optional, which means that we have to convince our fundraisers in a certain cycle how to, to feed into our programs and support us. So we do that essentially every 3 years. We have added to our portfolio also recently all the activities linked to transformational innovation for space. So all things linked to, let's say, artificial intelligence, the new way of dealing with services, embedding new IT technologies, and so on, is part of the activities. And this is also going to be part of what I will be saying later. What we are seeing today is that the space business, or the Earth observation business, is expanding beyond the traditional boundaries of Earth observation, how they traditionally were. Of course, the core business of a space agency is always going to be build satellites, build ground segments, operate them, and make sure they deliver the data and information. But we are also seeing a very steadily growing uptake of all of this information into all areas of society, and this is a core area also for the agency. So supporting all of that, supporting commercial initiatives, policies, all of this is becoming a bigger part of our portfolio, and that's also part of my department. Finally, I should like to say I'm a local boy. I was born not so far from here, so it's also nice to be back home for a change. Yeah.
Well, welcome home. And John, could you please talk about your role?
Well, thank you very much, Sarah. So, like Dr. Calvin, I'm also in an advisory role with my space agency. And being the science advisor, it means exactly what you think it means. But even more, I feel like it's my role to sort of stand up and represent science at all the tables where I sit. And that's whether I'm with the president or whether I'm talking to any stakeholder across the agency at any level. I also talk a lot about science externally. And that means I'm connected to groups across the whole of the federal government and all of the academic and industrial partners that the Canadian Space Agency has. And that means that I can play a large role in bringing people together to help to try to solve some of these problems. And I'm especially interested in how we can together create effective policy that's going to help us to advance our scientific mission in space. My own background actually is a little bit of aerospace and planetary science. So usually I am working on climate. It's just on Mars. So I've got to say you've got a really nice planet here. And I've enjoyed hearing all of the talks this week and all of the initiatives. And I really enjoy the things that we do in space for climate and for understanding the Earth at the Canadian Space Agency. So in terms of the priorities that I'm concerned with at the agency, I'm really, really focused on promoting activities and policy that are going to help us to grow the Canadian space sector. It's just expanding by leaps and bounds, which is wonderful to see. Also fostering some greater interlinkages within that sector, bringing us together so that we can address these kinds of problems. Making sure that space science is something that is an adventure for everyone, regardless of their background. And we're also looking to make scientific connections with young space agencies, especially those in the global south.
Thank you, John. So now you have some perspective on the context and where our panelists are coming from. And in general, we're talking about Earth observations data, and the nature of that data and the way in which they are collected, distributed, and applied really varies greatly across organizations. So I'd now like to hear from each of our panelists more about the type of work that they are doing and how they aim to engage the communities that they are serving. So Prakash, your organization is charged with providing Earth observation data to many government departments across India so that they can meet their operational mandates. Could you give us an example of a project related to climate change challenges that really showcases what you're trying to trying to accomplish?
Yeah, thank you, Sarah. So, as all of us have been debating since last 2 days, climate change is reality, and especially in context of India, it is going to have the profound effects of climate variability in many spheres of life in India. And India has been ranked a country which is going to be worst affected at the 4th level because of this climate change, mainly arising due to the vastness of the country and the different ecosystem which our country has. So space plays a very important role in terms of understanding the agents of climate change, like carbon dioxide, methane variability, as has been shown by Kate in the morning presentation, as well as to understand what kind of changes are happening in the ecosystems across the country. So, we have a mighty Himalayan range, which is around 2,400 kilometers long, the Himalayas, and a large portion of Himalayas lies in the Indian territory. That range is suffering from issues like, the glacier melt and snow melt runoff. Most of the Indian river systems, like the Ganges, Brahmaputra, and of course the Indus river system, they get water because of this melting of snow and the melting of glaciers. These glaciers are receding rapidly, and people have estimated that the climate change effects are severe in Himalayas. If we are talking of around 1.1 degrees Celsius change of temperature in the plain lands of India, but in Himalayan range is of the order around 3 degrees Celsius or so. So the Himalayan glaciers are receding pretty rapidly, so we are using space technology, remote sensing data, in terms of quantifying these changes, in terms of assessing the ice mass loss, and the kind of future projections in terms of water availability in the North Indian river systems, because they are basically feeding large amount of population in the country. Another important aspect is related to the severe weather events. Because of the climatic variability and the warming of the atmosphere, because of the high concentration of CO2, as has been told, the average concentration over India, we have measured at our Shadnagar campus in last 10 years has grown from 380 ppm to around 423 ppm. So what is affecting is the atmospheric variability, and the severe weather events are on rise, which is leading to rapid amount of floods. India has around 320 million hectare geographical area. Out of that, around 48 million hectare area is flood affected, which is almost 20% of the country. You can imagine, and the large amount of population of around 1.4 billion people in the country. So 20% of them are virtually facing the threats of the floods. So what we are doing, we are providing almost near real-time services using our microwave synthetic aperture radar data sets for providing information about the flood inundation areas to the administrators at the district level. Within 3 hours, this information is reaching. And we have been doing this almost for the last 15 to 20 years. So another very important aspect in terms of mitigation of the effects of this flood effects is in terms of developing what we call as the flood hazard maps for the country. So what we have done, we have accumulated last 20 years of flood layers, which we produce every year, and we are generating at 50-meter grid interval what we call as the flood hazard maps for the country. That means that at that grid level, what is the frequency of inundation, how many days this particular location was under flood, and based on that, the hazard severity has been classified from low, medium, moderate, and high intensity. What this data gives you, it gives an advantage to the policymakers and planners in terms of being ready for the future climatic effects of worse flooding scenarios. It is also a very good input for many of the insurance companies. It's also a very good input for the planners, actually, those who are going to develop infrastructure. India is one of the rapidly developing country with a GDP growth of around 8.4% or so. So this country needs this type of data, which is coming essentially from space-based inputs for planning purposes. Another very important aspect is in terms of developing resilience in the coastal areas. We have around 7,500 kilometer long coastline, and as has been shown, the east coast of India is vulnerable to the cyclone risks, the oceans are warming, and we are using space technology combined with the weather forecasting skills for mitigating the effects of cyclones, actually. Today, we are in a position to give the early warning 5 days in advance about the track of the cyclone and the location where it's going to hit and the wind speeds which are going to be there to the policymakers on the ground, and they are able to evacuate people from the areas which are likely to get worse affected. 10 years back, casualty figures from supercyclones used to be around 80,000, 90,000. Today, it has come down to less than 2 figures. So this is the impact which space technology has been making, and these projects in India are really making a change on the ground. So that's 2 examples in short time I thought will be interesting to
Thank you. Those are beautiful examples of using space-based data to really help with adaptation. So we're going to shift gears a little bit. So John, and talk about sort of a very different type of data. So Canada has satellites that are still providing valuable atmospheric science information that have been up for 20 years or more. What is the role of these relatively modest instruments in the landscape of thinking about next generation Earth observation data?
Well, I think these long-term data sets, they really take on an outsized role. And with every year that a satellite spends in orbit, the data set that it produces, it becomes more valuable. And it's not just the new additions that are important. Instead, it's also adding value to each previous year of data to have that longer data set. Now, the reason for this effect is that when you have the same instrument making the same measurement over and over again, and you're talking typically hundreds of thousands of orbits potentially over decades and decades, you're keeping that variable of the spacecraft constant and the instrument constant, and you really get to see the changes that occur in the system you're studying directly in that data set. So in Canada, we've got 3 of these missions or instruments that have a longevity of about 20 years or even more in some cases. And the first of these is a system called MOPIT. I won't go into the acronym on this one, but it's an instrument on NASA's Terra satellite that has been in operation since 1999. And what MOPIT measures is carbon monoxide, specifically carbon monoxide pollution in the troposphere. But even though it's just a single gas, modest instruments, like you say, it really is a critical way for us to understand pollution transport patterns in the atmosphere, and that's because the gas is fairly short-lived. So that lets us distinguish between human sources and also natural sources of emissions. And one of the most interesting applications, I think, of that data is to understand transport of those emissions to places like the Arctic. At those kinds of latitudes, materials are going to break down very slowly, and so the pollution can have a very outsized impact as it persists. And I remember earlier in my career, I studied how heavy metals that are emitted by burning coal, for instance, those can enter Arctic food webs, and you can see evidence of that kind of transport with MOPIT. So the second instrument is called OSIRIS, and that's an instrument on board the Swedish Odin spacecraft. That's been monitoring nitrogen dioxide and aerosols and ozone ever since 2001. And what we've really been able to see with this instrument and that very long data set is tracking how the ozone layer has recovered under the Montreal Protocols that were signed in the 1980s. And we can also see what happens when the climate is slightly destabilized by things like volcanic eruptions. So in 22 years, we've had something like 400 publications with this one, involving 300 different institutions. And the third and final example I want to give here, and we are really proud of this one in Canada, is the SciSat mission. So the SciSat mission, complete Canadian mission, it measures a variety of trace gases in the atmosphere. It's going to hit its 20th year of operation this August. And the gases that are monitored by this particular mission include carbon dioxide, methane, nitrous oxide, chlorofluorocarbons, and ozone. And that return data that we have from this mission, it's truly been a treasure trove. And not just for us, it's used across the world. We've got something like over 600 scientific publications involving over 2,000 researchers worldwide. And it's not just old papers, it's not a bunch of things that came out when the satellite first went up. The rate of publication on SciSat has actually been picking up as time has gone on. And in fact, there was a publication in Nature just in December based on SciSat data. So it's something that's being used, that's gaining in value to the community as time goes on. Now, of course, this longevity, it's a bit of a double-edged sword here, because none of these missions were designed to last 20 years. They were designed to last a couple years, and we've been fortunate that they've gone on so long. We've been lucky. So what we really need to start thinking about is how do we ensure the continuity of these kinds of data sets, these priceless data sets, with new missions to extend that record and make the data sets we already have even more valuable.
Thank you, John. And I think your example really highlights the value of open data for the scientific community and for having those long data sets, which can become more and more valuable as they continue. But I'd like to turn the focus a little bit to Kate. So you talked in your previous talk about how NASA has been really a champion of open data for decades and has really led that activity, which has been, it's really changed the culture of science in a lot of ways. So what is your vision? You talked about some concrete programs that NASA is doing, but what's your vision for how that data can be used not only for the expert users or for the policymakers in government, but just sort of for the average person? What's your vision for how they would actually be able to take advantage of the information that's available?
Yeah, thanks, Sarah, for the question. I mean, I think open science is incredibly important. It enables science, so the more we're open and transparent and provide that information, other people can use it. They can think about how what they're doing and the information they have connects to it, so we can get more interdisciplinary science by doing that. It also builds trust. If people can see what we have, what we did, and how we got there, we build trust in it. So there's so much value in open science. And some of the things we're thinking about, some of it is related to open science for scientists. So making, our data is publicly available. We have a lot of tools and resources we use to process that data. So making all of that publicly available. We have trainings on our data. We're translating some of those trainings into Spanish language so that we can get a broader participation in science and make that science go further. But that's for scientists. And as scientist uses data, we think about it a lot differently. I want data on a supercomputer in a netCDF format. And so that's what I want. So I benefit from the trainings and the tools from open science, but I'm looking for something very different than the average person. The average person doesn't have access to a supercomputer. They also probably don't know what netCDF is, much less how to use it. And so some of what we're thinking about is how do you move that data to something they can access? So putting some of the earth science data sets on the cloud. Thinking about formats, both the format of the data in its raw, cloud compatible formats, but also developing these tools and resources. So it's not that you're looking at a map of raw satellite data, but what is the derived product that you need? What are the questions that you answer? And how can we help get that? And that involves engagement with the communities, understanding what their needs are and how we can provide that. I mentioned a couple examples in my talk around the sea level rise portal and OpenET. We have an entire project called Surveyor that's joint with USAID, where we work with local communities around the world, in Africa and Asia and Latin America, to think about what are the challenges they're facing, how can satellite data help, and how do we get that data to them in ways that they can use it immediately. And it's that partnership and communication that's really critical to ensure that that science goes even further.
Thank you. That's those are fantastic examples of getting data into the hands of local communities and figuring out also what they need. And so that partnership is really important. So Runa, the community of users of Earth observations data has really exploded in the past few years, but there are still large sectors, and you mentioned this in your introduction, that aren't yet taking advantage of this resource. So how is the European Space Agency actively trying to expand the user base for EO data?
Well, the reality today is that, and we all know that in this room, is that we are in the golden age of Earth observation. We are sitting on a gold mine, a wealth of information, but that also requires and stimulates us to go beyond where we have gone so far, quite clearly, and this is at the forefront, I would say, of everything that we are doing in the European Space Agency to try to foster, stimulate, let's say, new applications, new services, and the overall uptake of all of this information into all areas of society. That's becoming more and more a mainstream activity of a space agency, and certainly one of a pan-continental space agency like ESA. So what we are seeing is a lot of work together with, let's say, new partners, new stakeholders, that aren't necessarily scientific. Of course, system science and modeling and data processing are still at the core of all of these things. But we are going beyond that, talking to organizations that are, let's say, more responding to or driving, let's say, policies, organizations that can be national, they can be regional, they can be European, or can be international. So organizations like the United Nations Environmental Programme, they work with us, let's say, to see how they can embed Earth observation-based services into their activities. For the same reason, we are working with organizations dealing with statistical information, the official statistics of all the countries around the world. These are massive data systems, massive endeavors trying to understand exactly the status or the value or of nature or the status of, let's say, all the economic indicators, including the value of nature. Ecosystems. So we're working with them to try to embed Earth observation data into the official statistics of all the countries around the world. This hasn't been done, and this is something that is completely new for this type of organizations. Then obviously, at the European level, there are lots of policies that are coming for biodiversity, for sustainable development, all of these things that require monitoring, that require verification. Yeah? And so we are working with the governmental structures, in particular in Brussels at the European Union, that deal with all these things. So the Director General for Climate, for the Environment, for Agriculture, all of these agencies, all of these organizations, they are keen to understand exactly what the Earth observation in space can offer. And so it means that we are going out beyond the traditional boundaries of space agencies, dealing with the scientific community. You mentioned the expert community. We know very well how to talk to them, but we don't know necessarily how to talk to people who do not fully understand, let's say, what space can offer. Yeah. So this is the main challenge that we are seeing. And so we have been able and successful in Europe to raise this somehow to the highest political level. So it's part of the dialogue between the heads of state. Yeah. And a bit more than 1.5 years ago in Portugal, there was a meeting with the heads of state in Europe where actually this ambition to take space to the next level was emphasized and highlighted and agreed upon. And this is, let's say, a mandate that is very nice for us because it gives us the possibility to work on the use of our data and our products to stimulate these sectors and make sure that we are not considered to be weirdos when we talk to people who are not normally belonging to the space community, right? So, and this is exactly what we are doing. We are working on a concept of accelerators that would stimulate the economy at the same time as we provide solutions for society. And these are linked to how we do things like, or support things like decarbonization, how we respond to crisis, and also how we further, let's say, work together to protect our planet. Yeah? So these are ideas that are being developed, and they are a direct result, I would say, of all of our effort to actually show the application and power of space. Yeah? And we are getting more and more into this dialogue, but from our perspective, and everybody who works in the space sector knows that, we are just at the beginning. Yeah? So we are having a gold mine here, and it's going to be not a mine of, let's say, limited resources. It's going to be one with growing resources, and we all have the obligation to work on this. And this is exactly what we at ESA are doing. Yeah.
Thank you. I think we've seen a lot with some of the information that Kate was presenting. We're sort of used to Earth observations, really helping us with understanding physical sciences, physical systems, the Earth system sciences, and the promise of expanding it to really social sciences, I think is quite exciting, and absolutely there's a ways to go in that domain. So when we think about discussing planning for the future, given the reality of climate change, the technical design requirements of new facilities are often the focus. However, the whole cycle from design requirements of new hardware through building to operations and then data distribution, integration, and applications really needs to be considered, that entire life cycle. So any gap in that chain is really a problem for using these valuable resources to monitor, mitigate, and adapt to climate change. So I'd like to focus on my questions to each of the panelists on different parts of this chain and talk about some of the gaps that they're aware of. So Kate, as a scientist who models climate, you're well aware of the holes in our science knowledge that really limit our ability to make accurate predictions of future climate. So which science gaps would you characterize as being the most pressing, and what is being done to fill them?
That's a great question. So just as context, before I came to NASA, I was a modeler, and I actually worked on 2 different types of models. One was more of a human system model that was looking at how energy, water, and land would evolve into the future and what that meant for emissions. So you could ask questions like, how much land and water do we need to feed a growing population in the future? Or if we want to limit warming to 1.5, what does that mean for energy, water, and land? The other model I worked on was an Earth system model. So it took the emissions in land from the first and projected future warming and precipitation, temperature, and everything else. So I'm going to give examples from both. And I'm going to focus a little bit on examples where I think we actually have positive stories where we're working to fill those gaps. Because a lot of the way NASA designs their missions are by polling the science community and figuring out what are those gaps and how can we fill it. So on the physical science side, I'll start with there. One of the questions in models, there's different components that affect warming, and one of those is mineral dust. And mineral dust, it either reflects or absorbs sunlight depending on its color. We have very, very sparse observations of it, so modelers assume that all mineral dust is an average color, or essentially yellow. We don't actually know on net whether it's warming or cooling, so in a model we give it an average color. EMIT, the instrument that went on the International Space Station last year, is going to give us better understanding of that spatial distribution of color, and so then we can put that into a model and actually understand on net, is it warming or cooling? The other example I'll give, and this is further into the future, on the physical science side, one of the big questions in climate, we know that carbon dioxide and greenhouse gases increase warming. We have narrowed the bounds of how much, so we've narrowed what's called the climate sensitivity in recent years, but there's still a range. So for every a ton of carbon dioxide that goes into the atmosphere, how much more does it warm? And some of that has to do with an imperfect understanding of clouds and aerosols. And so we have a mission coming up that we're working, just starting out through, called the Atmosphere Observing System. It's part of the Earth System Observatory. We have partners in that mission, but part of its goal is to better understand aerosols and clouds so we can narrow that uncertainty and better project climate change. On the human side, when you think about energy, water, land, and emissions, we use a lot of water when we grow crops and produce energy. But right now, the way we understand how much water we have in rivers and lakes, we have some stream gauges here and there, and we use models to fill in between. And so our base level, our historical knowledge, is based on a few sparse observations filled in by models. SWOT, the instrument, the satellite that was launched in December, will help us fill those gaps. So we'll better understand water today, and that means we can better understand how much water we might have in the future and how we can use that for crops. The last example I'll give on this, since we've been talking a lot at this conference about greenhouse gases. So in that model that I used to use to project emissions into the future, we have to start from how much emissions we have today. And what we use are inventories. So we use inventories like ones produced at the Environmental Protection Agency or the Community Emissions Data System. We use that to understand emissions now, but also emissions factors that influence how much you emit in the future. And by using satellite information like that from EMIT or some of these future missions to improve those inventories, we can improve those models and improve our understanding of potential future emissions.
Thank you. That's that's a lot. So a lot of science gaps, but it sounds like there's a positive story about how they're being filled by international collaborations to do that. So John, Kate mentioned the water cycle as part of that. So following up on understanding the water cycle, there's several current and potential missions that will capture water at different stages in the cycle. So one of them was the surface water and ocean tomography mission. But how could other facilities actually work together so that we can actually capture that entire cycle and not just the bits and pieces? Because of course water is in the atmosphere, it's liquid, it's ice, it's snow. So how do we capture all of that?
Well, thanks for the question, because really the climate, it's such a big topic. It's something to measure and to understand. And so no matter what mission or what instrument it is that we're talking about, we're only considering a very small piece of a much larger puzzle. But what we can do is we can build on the knowledge that we get from past missions, and we can start to assemble all of those individual puzzle pieces into a more complete picture of what's going on. And I can't help but spend a little bit of time lauding the SWOT mission as well. It's such a fantastic mission, and it's really a key mission for a country like Canada. It's going to be a game-changing asset. I mean, it's already up there, but we haven't seen, I think, all of the benefits of it quite yet as we're still working our way through the first batch of data. And really, it's going to change our understanding of hydrology. hydrology. And let me tell you why that's really key for Canada. So if you take a look at the world's lakes, they're not uniformly distributed. So in fact, if you take a look at a map of everything bigger than about 10 hectares, there's 2 large concentrations that you see in the world. One of them is right here in Scandinavia, but the other one is in the Canadian Arctic. And in Canada alone, you're talking nearly 1 million lakes. Most of these are remote, they're inaccessible, and it takes days, even if you just want to go and put a gauge in that lake to understand what the level is like and how it's changing. But the fact of the matter is, and we've been hearing about this all week, that what starts out in these remote regions doesn't stay in these remote regions. As water flows towards the ocean, it's going to pass through urban areas, and those urban areas are becoming more and more prone to things like flooding. So without knowing where that water is coming from and how it's moving, we're left to guess as to how it is that we can protect life and property in its path. And really, this is where it hits home to me. This is where space makes the difference. So with the data from SWOT, we don't just get some of the lakes, some of the time, or even a representative sample of the few tens of thousands of lakes that we had in Canada that were instrumented in the past. We get all of them, and we get them with frequent revisit too. And that's the data that's really going to change our understanding of hydrology and to really allow us to build resilience to flooding in Canada. And we can go even further. Where does that water in these polar lakes, where does it even come from? Well, a lot of it is present as snowpack. So seeing as I'm from Canada, I can't, resist the idea to talk about snow in climate. And if you do look directly at snow, what you can do is you can enhance the value of the SWOT data set. We're currently considering a mission that would do this, something called the Terrestrial Snow Mass Mission, or TSMM. And the idea here is that this is a mission that would provide 500-meter resolution KU band radar, and it would do that all across the Northern Hemisphere every 7 days. And what's really ingenious about this technique is it doesn't just give you the height of the snowpack, which anybody from Canada can tell you is going to vary depending on how densely that snow is packed. But what it gives you is the water equivalent mass, so you know what that snow is going to do when it melts in the summertime. And what we can do is we can combine those data, we can combine it with other planned missions, such as the upcoming Arctic Observing Mission that was discussed just the other day. And together, all of these satellites are going to provide even more data on this really, really sensitive region. That's going to help to fill in these gaps. And as we all know, and as we saw in Dr. Calvin's presentation earlier, the Arctic is warming far faster than anywhere else on Earth, which makes understanding how this region is actually warming and changing really critical to the whole global picture of climate change.
Thanks, John. And so talking about water and the issues for northern climates, so the north is warming quite a bit faster, as we talked about. There's issues of melting permafrost and snow cover. And those are quite obviously relevant for Arctic countries like Canada or Norway. But Prakash, a tropical country like India, you're naturally going to have different challenges. So you did talk already about water and the issues with glacier melts and snow in the Himalayas. But what are some of the other key gaps in information that you need in order to look after your country and your people?
Yeah, I think, Sarah, thank you for this question. Actually, especially if you look the kind of dynamics which is being played out in the tropical, part of the world is also having equal severity as what we are facing in the northern territories. We have talked about, various kind of, modeling efforts, but all models require observations. And one good thing which has happened in the last 4 or 5 decades that we had a continuity of several missions. So first thing is that before I talk about gaps, there is a strong need and commitment by space agencies to continue to have this observation so that we can build, our essential climatic variables, which we are already doing so, with the kind of precision which is required to understand the response of ecosystems to the changing climates. However, coming to tropics, as we were talking about the water is a real key and central issue in the tropical countries as well. So if I look into the kind of water demand a country like India has, where we have to feed around 1.4 billion people today, a huge population lives in that country, the 85% of our surface water requirement goes for agriculture purposes. So the crop water requirement is a real key issue which needs to be fixed up. And that's where there is a big gap in terms of having observations to understand the evapotranspiration and the kind of feedback processes we have in terms of understanding the soil moisture variability, which is required for agriculture practices. So India and Canes are coming together, and we are going to build a new satellite. It's called Trishna. I will not give you the full acronym here. You can find it out on the web. But what it will be a VNIR and a thermal imaging system, which will have a very high resolution, 56-meter thermal imaging capability from space, along with the visible and infrared part of, of bands in the electromagnetic spectrum. Essentially, this data will provide large amount of information about the evapotranspiration, both the actual and potential evapotranspiration. And what we are expecting that as a product, we will be able to tell to the farmers, at least at that level, that what kind of crop water demands are there and when they should be doing irrigation to their crops using this kind of products instead of wasting huge amount of water and doing flood irrigation, which is a prevalent practice in India for many crops. So that's a very important mission which is going to come up. Already it has been approved by Government of India, and Canes is also on board on this. So I think we all should look forward for this mission. The second thing which I thought is very important, which has not been addressed today, of course, there are large amount of changes which are happening over the surface of Earth. We talked about SWAT mission, and of course, there are a lot of land imaging missions are already documenting the variability which is happening on different ecosystems. But atmosphere is basically rapidly evolving and changing because of the amount of greenhouse gases which are getting into the atmospheric layers, especially the lower atmosphere and troposphere. We have had sounder missions from our geostationary satellites. India is operating 2 geostationary satellites called INSAT 3D and 3DR. We have this infrared sounders, but infrared sounders are having the limitation in terms of cloud coverage. You cannot get the sounding readings when there is cloudiness, and tropics suffer from large amount of cloudiness throughout the day. So we have been working on a technology called the microwave sounding technology, and we are now working to develop instruments in what we call as the millimeter wave range of electromagnetic spectrum. And this humidity and temperature sounder sensors are being developed in ISRO, and we have launched an experimental mission this year, and very good results are coming up. But equatorial region requires the 3-dimensional probing of the atmosphere in terms of understanding the humidity and temperature profile and its variability, which can go into models to understand that how the humidity and temperature are changing and will lead to improved nowcasting for the severe weather events. That's a key gap area which I feel which is not currently being addressed by space or Earth observation community, which probably ISRO is taking a lead in that. And second part is, which is also missing as far as the modeling and the meteorology community is concerned, we have been having the wind observations, mainly on oceans via our scatterometers. India has flown 3 scatterometers, and in December itself, we launched our OceanSat-3 mission, which has an ocean color monitor along with a Ku-band scatterometer. And the scatterometer data is very useful in terms of cyclogenesis, in terms of assimilating into the weather models to understand the weather dynamics. But what we lack today is the wind information over the land, which essentially is not coming from Earth observation data. Of course, ESA has a experimental mission of a Doppler wind lidar, but this type of observations needs to be put in an operational scenario so that our atmospheric models can improve over the land areas, and we will be able to understand fully the land, ocean, and sea interactions, as well as the land-air interaction processes by coupling wind information into our models. So I thought these are 2 major gaps currently which exist. I can give many other examples, but most of this has already been achieved. But 2 critical areas, especially the humidity, temperature profiling in cloudy conditions and the wind over lands, which we need to capture in terms of understanding the Earth systems together. I will just take 1 more minute, to talk about what Rune was telling, to translate all this, wonderful science data, which is understood by the people on the ground, especially the policymakers and planners. We are 2 technical people. We deal with technologies, and we expect and we think that everybody understands what we talk, but unfortunately, that's not the reality. So what in India we have been doing, we are taking these products, we are generating now the value-added products and parameters, we are putting on web-based services, And then we are trying to institutionalize remote sensing-based decision-making in various central government departments. For example, Ministry of Agriculture. They need large amount of data about the agriculture condition, the crop health, crop vigor, damage due to adverse conditions. All that is required. But those people cannot handle remote sensing data. So you have to put some people, your own technical people, into those departments and create that capacity and create institutional capacity so that they can educate the policymakers, planners, bureaucrats that how this data can be used and what kind of benefits it has. In fact, I am very happy to tell you now a lot of banks are basically coming forward in India to understand the remote sensing data. The banks are opening remote sensing and GIS cells simply because they want to give credit to farmers based on this data so that they have authentic data on the farming community. So things are changing rapidly. It is up to us, the Earth observation community, that how we can link. Opportunities are in plenty, and definitely Earth observation community is going to make a big difference. And we should look for a model which is demand-driven model. Like a cell phone is demanded by everyone, probably we should think that how Earth observation data can be demanded by various sectors. Thank you very much.
Thank you, Prakash, and I think you're absolutely right. We need to make sure that expertise is embedded where it's required so it can actually be acted upon. So I want to shift gears a little bit. So Runa, we've been talking so far about responding to climate change that's already underway and monitoring it and making sure that we understand how it's happening and the physical mechanisms behind it. But EO data also have the potential to contribute to achieving a green transition, which is an essential component of mitigating climate change. So how does that happen?
Well, I think
you can fix it, right? Yeah.
I think this is a very nice bridge from what Prakash was just saying. It hasn't been perhaps stated very clearly at this conference, but from our interactions in the corridors in this meeting, with the World Climate Research Program and so forth, we clearly have to come to terms with the fact that limiting the temperature increase with respect to the pre-industrial levels to 1.5 degrees isn't going to happen unless we do a radical change. I mean, this is the conclusion, and the climate researchers, they start not to believe in it at all. Yeah? Now, if we are going to achieve any of this, it will require fundamental investment at the level of trillions. It doesn't matter if you talk about dollars or euros or, well, you can scale it to any other currency, but this is the thing that we are facing. Now, there is not a single government, a single body, a single organization that can come up with this kind of money. It means that it has to be borne by everyone around the globe, right? So this is one of the main reasons why we have worked, and we try to start this concept of, let's say, having a dialogue and another way of working together in which none of this is somehow run by a single government, it's not run by a single organization, and certainly it's not going to be run by an organization like European Space Agency, because we, by far, do not own anything linked to the green transition. Neither do we own anything that is linked to the digital agenda. But we can contribute to that. We can enable things. Okay? So this is a little bit an idea that we are working on. I try to highlight one of, let's say, the political drivers for that in my first intervention here. So we've been working on something that we call Space for a Green Future. The idea is to go and talk to the players in this field, the stakeholders in this field, make sure that we look at ways to co-develop, co-design, co-own, or maybe we just have a kind of a foundation, not things that are just governed by the rules of a single space agency or a single organization at national level or at European level or international level, but everybody can be part of a kind of a movement that is supporting all of these things. So, what we are doing here is actually to come up, first of all, with practical examples that we try to seed this a little bit. We try to seed it with examples that show to the world, to governments, what space can do beyond what it has traditionally done. There's a very nice example that we have done with the country of Austria. We have created some sort of, well, it's maybe not the best of names, but we call it Information Factory, which includes, let's say, Earth observation data, models, but also data from all sorts of government into a kind of a digital twin, if you will, of Austria. The purpose of this is to inform government, let's say, what the total ensemble of information is worth in all kinds of areas: mobility, and clean energy, air quality, you name it. Yeah? Now, Austria is a country that is very beautiful, lots of mountains, it lives from tourism. Everybody wants a green country, but nobody wants to have, let's say, large parks of solar panels or ugly windmills just at the back of a beautiful alpine pittoresque village, right? So one of the things that we've been working on is try to find out how we can actually inform governments about the potential of, for example, wind energy. It can be also solar, can be other things. But also at the same time informing the citizens that are going to be affected by all of this about what this means. So you put together data on winds, models, you put together terrain models, you put together slope models, basically, and then you put into this system also, let's say, the existing power grid, and then you can look at, let's say, the potential, what kind of energy you can get out of it, and whether that is going to be sufficient. You can look at the cost, because obviously if you put windmills high up on a mountain peak, it will be more costly than if you do it deeper down in the valley. And you can take into account also things like distance to the existing power grid, such that you can somehow optimize the overall system. And for the people who live in the villages that will be affected by it, they can actually see directly in the system whether they're going to see this windmill or not. Yeah? So people are becoming sort of part and informed in the public debate. This is just one very simple example, but you can do it for mobility, air quality, you can do it for all kinds of things. And one of the ideas that we are working on is to do this kind of examples, not with the ambition to do it for everyone, but to show that the technology that is used to deliver this information is similar, by the way, to the dashboard that received the reward here on the first day of this conference. This technology can be used, can be scaled to deal with these things. Yeah? And we plan to make this technology available as a toolkit to everybody around the world who wants to make use of this and can build similar systems. And we plan to do more of these kind of seed activities to show what this can do. Another example is how we deal with air traffic, for example. So we have set up a collaboration with some of the major airlines in Europe, EasyJet, ITA Airways, and so on. And they look at how to optimize, let's say, not only the fuel consumption by looking at information that comes either from, well, of course, from air traffic management systems, but also from winds. And it also, optimizes when planes will take off, and so on. It can shorten, if you will, the time that planes are spending in holding patterns and so forth. And as an added benefit, it does not contribute just to the greening of society, but also to the passenger's experience, because it makes your flight shorter. So there are many examples like this where we try to sort of look into various sectors of society with this kind of applications. And we, of course, want to also to stimulate let's say, the economy around all of these things. This is what you were talking about. So we talk to the financial sector, just like you do, because they need to come into play here to support all of this, to fund some of these activities, fund businesses that want to create and let's say, do business around all of these things, with the overall aim, actually, that at the end of this, the game will be that some of these applications that in the beginning are initiated by space technology, get scaled by these other organizations and businesses that would like to support it. And this is the way that we think and hope, at least, that on a time scale of, I don't know, 5-10 years, we will see a significant momentum into this type of activity. So this is what we are trying to achieve. Now, it's not a done deal, because it requires funds, it requires activities, but we are quite sure that placed correctly on the political agenda, and placed correctly in particular as a business opportunity, this can actually be one of the major contributors to the green transition of society, and by the way, also to the digital agenda that is, of course, on everybody's mind as well.
Thank you, Runa. So we now have just a few minutes to take some of the questions from the audience. And one of the questions has to do with mitigation. And I think actually we've had a lot of beautiful examples of how space data can be used for mitigation. We talk about technologies that are developed for space exploration, which I think is actually the interplay between space exploration and Earth observations hasn't really been explored very much at this conference, but I think it does have great potential to really develop technologies and push boundaries of what's possible so that they can then be brought into the Earth observation sector. But there's a question that I want to pose, and Kate, I'm going to start with you on this because I think it's quite interesting to think about. So is competition in the space sector, in observations, data analysis, et cetera, beneficial or detrimental to our global objectives in understanding the climate? We've had a lot of discussion of the interplay between the private sector and space agencies and countries, and so I think that's a valid question. How would you answer that?
I'm actually going to start by talking about competition not in the space sector as an example and then work my way there. So in the modeling world, having more than one model is viewed as a good thing, both because there are uncertainties in the way we understand the Earth system, that having more than one approach can be really beneficial because you can capture that by comparing. And if you get the same answer from two different approaches, there's real value in that. There's also value in coordination in that world. So making sure we're not exactly duplicating, but instead making sure that what we do adds. And I would say, think about something similar in this space sector. There's areas where partnership really makes a lot of sense. And we do partner with a lot of people so that we can pool our resources, pool our innovation, and make things go further. But there is also, there's always a little bit of healthy having more and trying to make it all work together does spur innovation and can drive change.
Thank you. Does anyone else want to take a stab at that question as well? Go ahead, Runa.
Well, I have some experience. I happened to work on a certain magnetic field mission of the European Space Agency, and we had 2 magnetometers on the satellite. And the first lesson learned by the scientific community was if you have 2 magnetometers on the same spacecraft, well, that's not a good idea, okay? Because you get conflicting answers. Yeah? Said that, it took us on a journey of about 5 years trying to find out why the measurements were different. And at the end of the journey, everybody learned, and actually were very happy that you had those 2 magnetometers, because you actually not only could you correct the measurements for that particular satellite mission, but you can actually use it also for previous magnetic field missions and correlate that to what has happened on other spacecraft. So the conclusion of all of this is try to avoid lock-in with anybody. Yeah? Make sure that you have as much diversity as you can. Work together. And it might be hard in the beginning, but in the end, we all benefit. Yeah.
All right. Well, I think that we've come to the end of our time, so I think that's a great note to end on. And let's thank our panelists for their really insightful comments.
Thank you very much for this great session and for the moderation. May I also ask you again to line up for a group picture? No, I think it's fine if you're just standing. And for all of you, thanks for being with us this morning. We are breaking now for a coffee break for half an hour, and would like to see you back again at 11 sharp. We again need to reconfigure the room, so please, if you could help us to free the room as quickly as possible. And the technical sessions will also continue after the coffee break. Thank you. Welcome back, ladies and gentlemen. Let us kick off this first Global Networking Forum session of today. The climate phenomenon, climate change phenomenon, is triggering a series of global polycrises, as they are called, such as natural disasters and extreme weather phenomena. Some of these effects are already reaching the tipping point and suggest that the sustainability of human life may be incompatible with the available resources we have. And to dig deeper into this question, we are now offering you this GNF session that is titled Polycrisis Linked to Climate Change, from shortages to socioeconomic impacts on future generations. And this is organized by the European Space Agency, ESA. And it is my great pleasure to welcome on stage Maria Gabriela Sara from the ESA Strategy and Foresight Department. Maria Gabriela, the floor is yours.
Thank you very much, Christian, and welcome to all. Yesterday we had a first panel with tackling a bit the next generation challenges and specifically, what were the issues they were facing with those, as Christian said, with those polycrises. Now, today, I would like really to address concrete actions we are doing, and I'm happy to see that there are more senior people than during the yesterday Space Generation Advisory Council panel, because we just realized that basically there were many young people, and today it's nice to see that we are all engaged, and it's not only the new generation who is engaged in this fight, but we are all engaged, and whatever the generation. So with no much ado, I want to call my distinguished guests to come and join me here. So first, I have the pleasure of welcoming Laurence Monnoyer-Smith from CNES, here the head of sustainable development at CNES. Thank you for being with us. So you represent a space agency. Then Thomas Marceau, again head of sustainability, representing more the industry side, Ariane Group. Thank you. I want to call an engineer and great specialist in water, Mr. Jean-François Donzier, Secretary General and former General Director of the International Office for Water, Global Alliance for Water and Climate. Great specialist in water. Thank you for being with us, Professor. Hilde Roth, Senior Vice President, Climate and Sustainability at Equinor. Thank you. So nice to have you with us, Hilde, because you're outside the space world, even though, of course, your company uses space images on the field, and you will be telling us a bit what concrete actions you're putting in place. And last but not least, Professor Laetitia Thirion Lefebvre, coming from one of the leading engineering schools in France, professor in remote sensing, and one of the unique engineering schools having remote sensing in their first year of engineering. So thank you for being with us. So, well, thank you again, all of you. I think we have a very rich and diverse panel, as you can see. And I would like already to address you, Professor, because you are dealing on a daily basis with this new generation. How do you ensure this new generation is prepared to be confronted with this climate change? How are they reacting? And what concrete, things are you putting in place at your university?
Thank you, Maria Gabriela, for this question. It's true that it is a clear demand of our students to be prepared. It's our responsibility to answer them to this question. And maybe to better set up the context, I propose first listening to a first video extract from a master's degree's graduation in France.
Now, on to the parents, managers, alumni, and to all those who might think we don't have enough experience to really understand. Don't leave us to face these challenges alone. Climate and biodiversity are not reserved to your children. Learn about it. Tackle it. Let's upskill together. And if you are already in positions of power in which we could be one day, Transform your companies today, because every ton of CO2 matters.
Yes, do not leave us facing alone these challenges. What a call. What a call, what a responsibility for us. So these future generations need us. They need our support, but how to accompany them? This is exactly, I think, the goal of this roundtable. Actually, it's my daily job in my lab. I'm a professor in remote sensing, as you say, and I'm supervising PhD students in order to study forests, for instance, oceans. And actually, we supervise maybe 5-6 students per year, PhD students. It's not enough. Clearly, we have only a lucky few students with them. So the question was how to increase this number of students and how to increase our impact. And to do that, I will illustrate my answer with three examples. So first, we propose what could be seen as a regular course, academic course at Centrale Supélec. But actually, it is different. We are not only giving them, it's not a course about climate change. We are not delivering information to them because they already know a lot about it. But what we are doing is that we try to empower them, to make them able to process these space data, like in the Copernicus program, so that they can observe and measure, for instance, deforestation throughout the world. It would not have been possible alone. We benefited, as you all do actually, from the support of the European Union, which developed the Copernicus program and delivers for free remote sensing data of the Earth. But how to reach more students, more colleagues? This leads me to my second example. We developed in collaboration with the European Space Agency and NOSA lab on climate change and space exploration. It took time. It required discussions. We had to convince other professors to join us. But now, a new teaching and research activity exists on circular economy. Is it enough? Probably not. When we listen to these students, as Anne-Fleur Le Gall, that you just heard at HEC, during their graduation ceremony, a lot of students expressed their anxiety and their anger. Anxiety because they do not feel enough prepared. They do not feel sometimes prepared at all. They reject their diploma. And anger because they feel alone.
Quite violently, as a matter of fact. You have some examples in France, where they rejected their diploma.
Several ones. This is a clear crisis, actually. And this brings me to my last example. We are working now to a dedicated version of our engineering courses over 3 years, where ethics, sociology, philosophy, local economy, and ecology, for instance, are now parts of the technical problems our students have to solve. Engineers like maybe most of you in this room, have to rethink the way to reformulate the problems. They have to integrate the needs of society in terms of health, food security, employment, for instance, local employments. Your technical choice, their technical choices have an impact. And again, we cannot do it alone. It is not enough to have the approval of our hierarchy. We need them to be committed. We need them to accept, to try for real, maybe to fail, and to try again. You may be surprised or maybe not, but even if we only talk about teaching today, for me, we have to face money and administrative issues as well. At that point of my career, I strongly believe that the first step is to properly set up our fundamental objectives and to regularly check that all our decisions and actions are aligned with them. My fundamental objective as a professor is to innovate and to transmit, to help this future generation to face with us the challenges to come. To do that, we are strongly motivated, but we need money and we need people.
Thank you for that, and thank you for being so direct about the fact that we need people engagement's money, and thank you for having mentioning a word which I like, which is ethics. We had some discussions with some colleagues in the last 2 days about ethics, but it's a very important one, and therefore I would like now to transition to Thomas. Thomas, you are part of, let's say, the launchers, producers industry, one of the industries which has a very visible impact, let's say, on the environment. I understood last year, in 2022, you had some severe events, weather events,
on our site,
affecting you, affecting your site in Kourou, etc. You can tell us a bit maybe about that. And what did it trigger within your employees? Because it did trigger something, and maybe you can tell us a bit about it.
Yeah, just before getting to that question, you mentioned the visible impact of the launcher industry, and it's true, it's a visible impact. I mean, a launcher, it emits a lot of smoke, it's noisy, it's a flash, it's a very powerful event, so it's like the tip of the iceberg, but that shouldn't prevent us from taking care about our own impact along the whole supply chain, along the whole life cycle of the products. Because the launcher event is one event, but before doing that launcher, to manufacture that launcher and to manufacture a satellite that we will launch, you need products, you need extraction of resources, you need water, you need energy, and that takes a lot of time, a lot of energy, and then to exploit the satellite when it's launched, it also needs resources, it needs energy, it needs data, and so on. So we need to take care, all of us, about our own impact all over the life cycle. So it's really important to say that, not to focus on one single event of the life cycle. That's the first point. But coming back to your question, actually 2022 was a very bad year, so to speak, for the launcher industry in general. We lost the access to the Soyuz launcher at the beginning of the year with the war in Ukraine, and we had a failure of the Vega launcher at the end of the year in December. So it was already a crisis year in itself. And in the middle of the year, during the month of June, we have had some severe climatic events on one of our sites in Bordeaux, near Bordeaux. We've got a major hailstorm with hails the size of a tennis ball, approximately. Very big hails, which went through the roof, destroyed part of the production tools, crippled the sites for several weeks and months, and on top of that, people were affected. I have been affected. I have had some hails going through my roof. I've got water all over my living room, so I can tell by experience, and that really spoke to the employees. And if it was not sufficient, then a few months after, we've got wildfires in the southwest of France, huge wildfires near the Bordeaux area, not on our sites, hopefully, but close to our sites. So that really triggered a kind of wake-up call in plenty of people inside the company.
Yeah.
This was really important because before that, we had also, of course, roadmaps ongoing in order to reduce our own impact, to reduce our energy consumption, to reduce our CO2 impact. But then after that, plenty of people came to us and said, okay, but what can we do? I mean, okay, this is real. I mean, most of them had heard about it, but it was one of the first times they were directly struck in their daily life by such an event. In their production tools, in their daily life, they have been hit. And so they wanted to know what could they do. So we started to act. We were already working on mitigation, but we started to act on two very important axes. The first one is awareness. We started an awareness to all employees regarding climate change, ecological transition, and so we aim to have trained all employees by 2025, 100% of all our employees, and they were really happy about that. They were really happy that we address the problem, that we inform them about that, about the consequences, and what can they do in their everyday life, on top of what can they do within the industry as well. And we worked also on adaptation, because mitigation is one thing, but at some point also we will need to adapt and to get resilient. So we started some risk analysis about what could happen on our site and how we can adapt to these changes. So in a way, when people get very confronted to reality in their very daily life, in their core, that this triggers something. And I should say that in every crisis there is an opportunity. It was a crisis, of course, but this was the opportunity to mobilize against the people and to make them move in the right direction. So this has really triggered a kind of wake-up call.
Yeah, like in every bad event, we can do our lessons learned and grow up from it. But the thing is to do our lessons learned. And I'm happy to see that really Ariane Group, you have put in place these trainings. And not only, as you mentioned, this is quite a nice thing, not only in their professional life they're going to be trained, but as well giving them tips and tricks for their personal life. And it's a bit sad that we had to wait, that we were struck by such events to react. But at some point you need a wake-up call, as you
actually,
said quite clearly.
We wanted to do that, but that was really the triggering event.
Yeah, thank you so much. I will turn as well, there are many triggering events in other domains, like in water. We talked about those different shortages, and there will be shortages in the future in water due to the climate crisis. Jean-François, you are an expert in water management, well-renowned, worldwide renowned, I could say. Do you think today that even though it is so clear and so obvious, there is a real political will to mitigate the risks linked to shortages of water? Is there this will existing at political level? You have been in several fora all across the world. What is your feeling about that as of today?
So, as Thomas said, floods, drought, waterborne disease, shortage, pollution, wastage, destruction of ecosystems. The seriousness of the situation in many countries require that a new management of freshwater resources be quickly implemented to preserve the future. Global warming exacerbates this situation and tensions as one of the first consequences.
You want to show us? Okay. Some slides. Okay.
Global warming.
Time bomb.
The second one.
So a time bomb.
Okay. So global warming exacerbates this situation and tension as one of the first consequences is to increase the frequency and intensity of flood and drought, not only drought. It will be worse and worse very soon. Business as usual cannot continue, and we have to react immediately. Adaptation to freshwater management is urgently needed worldwide before it is too late. And quick actions will allow reducing cost and damage. We are worried about the unknown action cost. Of the 17 Sustainable Development Goals of the United Nations, 9 are correlated with water, which proves the importance of water in human development and environment. European water policy today includes legal frameworks far ahead of most other regions of the world. The experience acquired by the EU for several decades now show that progress is possible, but require long times and very substantial multi-annual financial resources. Elsewhere in the world, there are leading countries such as Israel or Singapore, or others which are already well on the way to reform, but they are still too few. In too many countries, lack of political will, centralism, sectorialization, bureaucracy, weak financial mechanism, and sometimes corruptions, or more simply insufficient human resources and skill, delay urgent reforms. There, despite of the great speeches, in the absence of a modern institutional framework organizing an integrated water resources management, the strategy remains not clear, the projects are not developed, and the confidence of investors is not yet there. Even if innovation is even if innovation is always necessary, the main difficulties encountered are not technological, but institutional, managerial, financial, and educational. Integrated water resources management must be implemented in all the countries of the world and be organized on the scale of local, national, and transboundary basins of rivers, lakes, and aquifers. Better managing water demand, water saving, leak detection, recycling, reuse of treated wastewater, groundwater recharges, desalination of seawater, adaptation of new crop varieties, research on low consumption use must become priorities. A new approach of water uses in agriculture should be looked for, as the farmer will be among the first victims of the variation of the climate. But we cannot manage what we cannot measure. Today, data in water sector and information are too often dispersed, heterogeneous, incomplete, and are rarely comparable and adapt for objective decision making. Information systems are priority tools to be implemented, and we need this kind of tool mainly for the countries where groundwater measurement facilities are not sufficiently developed or are difficult to access.
So data is very important.
No. The surface water ocean topography satellite, SWOT, will allow to measure the level and slope of main rivers and lakes, and to estimate the flow as well as precisely determine the level of the oceans. In conclusions, to answer your questions, nothing can be done in a short time, but adaptation will take several decades before having visible effect. Today, the financial resources devoted to the management of water resources are everywhere insufficient in the context of the current changes. Mobilization is essential to prepare the future. This is no science fiction. The solution exists and works in many basins in the world, mainly in the European Union. But today, it's useless to reinvent the wheel, as all the effective tools are available to move forward, if there is a political will to decide to do so. So let's get mobilized.
So you still keep the door open. There is some hope. If there is the political will, we can do actions. And thank you as well for mentioning well, the fact, I think you're in line with what Professor Laetitia Thirion said about the fact that, okay, we can put in place things if there is no will behind from the higher spheres to push the implementation. I mean, we cannot go far. And thank you as well for mentioning the wastewater management, treatment, etc., because this is typically the circular economy projects we were talking about. We've put in place with our ESA lab, with the university Professor Thirion is working at, the engineering school she's working at, as a matter of fact. And you know that at ESA, or you might have heard about a project called Melissa, so I'm doing a bit of publicity here for my own agency, the project Melissa, which is a microecological life support system which really works in closed loop, where we are reusing, and we did it actually on the International Space Station, reusing to be in a closed loop, to be able to retreat urine, etc., grey water, yellow water, black waters, to retreat them and get some water for other uses. So this water recycling is definitely something super important, and it is the future. Now I would like to turn towards Hilde. Hilde, again, thank you so much. I find your initiative to come really a nice one, because you're outside the space sector. As I said, I mean, you work for one of the biggest oil and gas producers in the world, Equinor. And at the same time, well, one of the biggest also producers of greenhouse gases. Let's not, let's face the truth. Nevertheless, I'm happy that you're here because, it brings something to the debate. What concrete actions are you putting in place within your company? Because at some point there will be a transition you'll have to face, and towards also the new generation to attract them. Because, as we said, and as Laetitia said, I mean, we really have very violent, at least in France, I don't know how it is in the rest of the world, but I can talk about my own country. We had some violent reactions where some students refused to have some oil producers on their sites. In the United States, I know at least that some big universities like Harvard or MIT have refused as well some funding from such companies. So they're refusing some funds. It is a big thing for such universities. But I know you're putting in place some concrete actions with your employees and also for the new generation. Can you tell us a bit about what you're putting in place? Thank you.
Thank you, Maria. And indeed, as an energy company and as oil and gas producer, we're very much at the sort of core of this polycrisis of climate change. Oil and gas, of course, is a big source of direct emissions, but more importantly, also a source of indirect emissions when our products are used in other sectors as well. And this is also why I believe energy companies have such an important role to play in tackling climate change, because to be able to really handle climate change, you also need to solve the energy question, and you need to decarbonize energy systems. And I think we've seen quite clearly, and particularly the last year, that we need to reduce emissions, but we also need reliable and secure supply of energy, and we need affordable energy. And today, 80% of the energy system is still based on molecules. So it's a massive task. And unfortunately, it will also take time, so there are no quick and easy solutions. It's going to be really hard work for energy companies, but also for all our consumers, all our customers. But I do believe that we can do something, and we are very focused on sort of putting in place actions. I believe this is a joint challenge for society. And we have technology, we have skills, we have employees who are very motivated to take part of this transition. We've worked for decades on reducing our own emissions. I think that's a very good starting point for any company, anywhere in the world, and also for other institutions. In fact, if we all managed to reduce and eliminate our own emissions, problem solved. So that is, something very effective everyone can start working on. And from an industry-leading position on being an efficient, carbon-efficient oil and gas producer, we have set out an energy transition plan last year. It was something that was voted upon by our investors, an advisory vote at the general meeting. And we're now reporting on this every year. So it's a very public commitment, ambitions, and also accountability that comes with that. It's built on our strategy, which is to produce oil and gas, which we will need for decades still, with as low emissions as possible. It's about growing in renewables, which we need to replace fossil fuels. And it's about also developing low-carbon solutions so that the oil and gas that is needed for the hard-to-abate sectors can be decarbonized. So with carbon capture and storage, and with hydrogen solutions, for example. We've set out clear ambitions, and one of them is to reduce our own emissions with 50% by 2030. The other one is to change how we invest. And there we're really aiming for 50% of our investments to go to renewables and low-carbon solutions by 2030. And some think that's a lot, and some think that's too little. But up from 4% 2 years ago, I think it says something about the pace of change in the company. We're also looking for solutions to handle the emissions that are from the use of products, the so-called Scope 3 emissions. That's a lot tougher because you need to do it in partnerships with your customers. But we have what we call a net carbon intensity ambition to reduce, in a way, the overall emissions that come from the energy that we provide to society over time, towards net zero in 2050. We strongly believe that just cutting energy supply is not the best way to handle this crisis. It is to build out the solutions. So this is why we're very proud to have Dogger Bank, the world's largest offshore wind field, will start production this year with Equinor as the operator. And next year, we will see Northern Lights in Norway, the world's first open source carbon capture and storage plant, into operation. So actually capturing and transporting CO2 from other industries, such as cement, for example, or the waste industry, and then injecting it into reservoirs in the North Sea. And the capacity there is 1.5 million tons per year. And that is booked and overbooked, more or less. So that's full now. So I think the potential there is enormous. It's taken a long time to get there, but I'm really hopeful for that. So we try to show with these actions, and I've shown here the progress report, because we do report very openly on progress, and that creates a lot of discussion. You know, what's good enough? Is it fast enough, etc.? And I think a lot of the dialogue we have, particularly with students, but I would say with people of all ages, are around the pace of change. Because that's really what's too fast, what's too late, and how fast can you move as a company compared with society. But we really believe that being very transparent on where we are and what we have achieved and where the challenges are is really something that sparks a good discussion. So I think we can all do a lot, whether we're in the energy sector or in other sectors. You can handle your own emissions. You can be transparent about the emissions you have, and we have good help from the space industry there. But we can also use our voice, whether it's in how we procure, setting clear requirements, how we advocate for policies and regulations that are actually Paris-aligned, and then being very transparent on not only ambitions, but also on actually your results.
Thank you for mentioning the transparency, because indeed, I mean, it's a domain where we do expect some transparency, and I suppose the new generation as well expects it from you, and also to mention, you know, the policies to be put in place, because you are joining a bit what Jean-François said about the political will, and Laetitia as well, and I think this is, thank you for this openness, basically, and I'm impressed if you get by net zero until 2050, I wish for it really, and yeah, the investments as well, you mentioned how to invest in an intelligent way, question ourselves, is definitely not only for your area, but for any area for the future. This is something we have to tackle. Now I turn to you, Laurence, last but not least, because you are the head of sustainable development at CNES, as I said, and you deal on a daily basis with the industry, the space industry, with whom you procure your satellites, etc. And so you work closely, for example, with Thomas and with other industries. Do you think you as a space agency, and I'm also a space agency, so I also take it for me what you will say, what are we doing enough towards sustainability? Or do you think, are we doing enough ourselves? Is it, because we are also public organizations, and what things could we be putting in the future, but are we doing already enough today, maybe?
Well, I think I'm going to be really straightforward to everyone here, and we are far from doing what is necessary. Far from it. What we have been discussed in the last 2 days and a half is basically dedicated to all the great things we have been doing to help climate and to monitor climate. And it is true, for the last 30 years, the space industry has been doing a lot. It has helped the scientists, it has helped to define the modelization, to help to understand the climate, how it's working, and that is true. But that is 10 to 15% of the space sector activity, max. The rest of it is telecommunication, defense, and other type of activity which has nothing to do with saving the planet. So basically, for the last 2 days and a half, we have been congratulating ourselves for everything we've been doing, not discussing our own footprint. How many of us here do a GHG inventory every year or every other year and know exactly the weight of a salary in their company in terms of carbon footprint? I can tell you, for CNES, it's 27. It's massive. Absolutely massive, and this is only scope 1 and 2. If I add the scope 3, we're above 100. By 2050, we have to go down to net zero. How many of us have actually planned very seriously the decrease of their carbon emission to be sure that they're going to be net zero in 2050? I'm afraid very little. Not only that, but we haven't asked ourselves if what we are planning for the next 30 years, hundreds of new launches, hundreds of new satellites, are compliant with the limits, the boundaries of the planet. Are we asking ourselves together what we have to stop? Because it is not sustainable. It is not compliant with the planetary boundaries. This is what we should do. Spend 50% of the time in this type of conference saying how we are helping the planet, and spending 50% of our time how together we can actually organize ourselves to be net zero by 2050, what we have to stop. Come on, do we have to develop activities in space tourism? Do we have to develop Internet of Things? We know Internet of Things is not compliant with the planetary boundaries. It is not. Everybody knows that. So what are we doing? So basically, I'm calling urgently for, stop the denial. It's not because we're doing great things that it is sufficient for us. It is not. And if we don't decide it ourselves, if we don't say ourselves, the space industry, what we want to do, where we want to put the effort, everything we want to, how we want to be compliant, somebody else will decide for us. Politics or the society will tell us, okay, that's great. You have modelized the climate. Now it's done. We have enough data. Now we're going to put all this public money in helping the poor people who are dying because of drought. Or to have water, to have a great water system, because this is going to be a major issue and probably more important than us developing new Internet of Things, services. So if we want to be responsible, to keep our jobs, to be sure that the people working in our company still have a job in 20 years, we have to decide what we want to do, and we have to decide it collectively. Sorry, I'm really being blunt, but we cannot be in denial in a kind of don't look up fashion, which is kind of contradictory with what we're doing, honestly. I think we really want the next GLOC conference to be the start of something new for the industry, saying the space industry has a very important role to play, but it also has a footprint, and we have to be net zero by 2050. We have to.
Otherwise, we'll discourage our next generation. Thank you. Thank you so much for this energetic talk. And I would like maybe our other panelists to react maybe to what, maybe you, Thomas, because you're the industry and...
No, I'm fully in line with what Laurence is saying. I mean, it was the whole point of our panelists today, and it was the whole point of me telling before that we need to focus on the global life cycle and not specifically on the launcher or whatever. Everything that we do has a footprint. It's true. You cannot do anything without having a footprint. If you don't have a footprint, then you do nothing. So we need to address at each and every one of us what is our footprint, what are the impacts in terms of climate change, in terms of water consumption, in terms of resources consumption, in terms of all the impacts that we have, and to address them very, very, very carefully. Fully in line with what you're saying.
Laetitia, you are also nodding, so I think you are fully in line as well. You as a professor, dealing with the next generation on a daily basis, it is something which strikes you, yeah.
It's our responsibility to be coherent, to be reliable, otherwise the young generation will just run away from us. And I think we need to be together in order to try to solve these numerous issues.
So next GLOC, so this is for the GLOC organizers here. By next GLOC, we will do some working groups where we all brainstorm together on how to change the space industry. It seems that the oil industry is doing fine because they have a transition plan and they're fine by 2025. But okay, we should already in our own home, which is the space business, try already to
just to complement on that and regarding the young generation or whatever you call it, but for example, each time I go to a university school or when I talk about space industry, the first question I get is not wow, space satellites, great, that helped me with my cell phone, that helped me with my I don't know, with monitoring the forest or monitoring the state of the planet. The first question I get is what is your impact?
Space debris as well. I get it very often
as well,
when I go to lecture.
Why do you want? Why do some of us want to go do space tourism, something like that? So the first question is about the impact, not about all the benefits that space can bring, which everyone agrees about that as well. No offense about that, but that's the question of the impact. Yeah.
So based on this reaction, I would like to ask you a question. Okay, so we know that the situation is maybe not as pink as it should be, and you said it quite directly, I would say, Laurence. Then let's say you're a king or a queen of a day, okay? You have the power of changing things. What would be your first action? Who wants to take on the floor? Okay, Hilde, go ahead.
I can start. And first of all, very also loved what we heard right now, but because we do need this action and really looking at our priorities in every sector, every industry sector. But if I were king, a global king or queen of, I would actually start with a global CO2 tax, which will probably never happen, but there is something about making the fiscal system and economic system also work for the environment. So we've seen that work extremely well in Norway, and I think it would have changed a lot.
Thank you. Global CO2 tax. Jean-François, you wanted to react as well?
Just look, Trump will not be re-elected.
Trump will not be re-elected.
And maybe we pray to have a new parliament in the European Union.
To pray for a new parliament.
The climato-sceptic will not be there.
The climato-sceptics are not there, okay.
Because 2030, it's in 7 years.
It's true, 2030.
So clearly, I share your advice.
Tomorrow.
It will be very short.
Indeed.
Even 2050. So we have to look at maybe the end of the century if we react immediately. So click, we react immediately. And we have money and institutional tools for doing it.
You as a king, that's what you would be doing. And money and institutional will to push things now. Okay, thank you. Anyone? Laetitia, yes, go ahead.
Yes, maybe I think that it's okay that companies are here to make money. It's important for them. But maybe if I were the queen of the day, I will oblige them to add a new mission. It's to contribute to a better life, an obligation for them, how they contribute to a better life.
So ask every single company, how do they contribute to a better life? Let it be for their employees, but also...
Yeah. They show how they contribute, not only to make money.
Not only to make money, so not be only profit-oriented, but having an obligation towards creating a better life. Thomas, Laurence?
Yeah, I can go for it. I would, in quite the same vein, I guess, I would make that at the international level, maybe the UN level. Thanks to the COPUOS or whatever organization, international organization can do that. An international agreement like the Space Treaty we had in '67 at the same kind of impact, engaging the whole space community to stop to develop everything which is not within the planetary boundaries.
So IoT, etc. Internet of Things, and Okay. Obliging the whole space community to really adhere to these new laws. Thomas?
Each time we have discovered a new source of energy, we have never got rid of the old ones. That each time we had woods, and then coal, and then fossil, and then nuclear. And but each time we found a new source of energy, we never get rid of the old ones. So first law as a king of the world would be to ban one old source of energy, which is coal, which is today a horrible disaster in terms of CO2 impact all over the world. So to stop coal all over the world, stop coal production, coal factories or whatever.
Okay, that's definitely something we're going to go towards, but maybe not in the as of today, unfortunately. But you're the king of the day, so you can choose it.
Well, we will lack electricity, of course, but we'll live through it.
So now I would like to turn to the public because we still have 5 minutes. We have also a microphone. So is there someone who wants to react in the public, to be as direct as Laurence, or to have a question to challenge maybe also the panelists here? Please, Leo. Leo McKay, Chief Sustainability Officer from Lockheed Martin.
Well, I had a question, but I'm going to change it.
Okay, go ahead.
Because I was surprised by the tone of the discussion. And I guess in the theme of being uncomfortable, you know, what would this panel say to the Global South? The black, brown, and yellow people, 1 billion or more of which that are emerging from poverty and need energy resources to do that. You know, in your statement about, you know, we all got to buckle down, we got to stop producing, stop consuming. Those people are just starting, and it's not about luxury. It's about subsistence, and it's about emerging from poverty. So, what does the developed North say to the Global South in that construct?
Who wants to respond?
I can answer to that. This question has been raised during the last COP, and you're right, there are 2 answers to that. The poor people are the first one who are suffering a lot. All the vulnerable countries and all the people you're mentioning are suffering a lot more than the northern people about climate crisis, a lot more. So that's the first thing. The second thing is that the decision of the mobilization of the northern country in order to help them to develop in a sustainable way has been discussed a lot during the last COP, and the decision has been taken and it has been quite controversial to create a specific fund to help them to develop, and this by using renewable energy, and to help them to do so. One cannot say that we are going to continue to expand GHG emission, which has a very terrible effect on those population, just because we think we need to help them. This would not be the best way to help them. What is true is that we have to cut our GHG emission a lot more than they do. And this compensation system has to be done at the international level. That's true. But we have to help them out that way, but not by developing continuously GHG emission with fossil energy.
Thank you, Laurence. Are you convinced, Leo? No? Go ahead, speak. We want controversial ideas here.
I mean, I'm an American. We learned we were second-generation imperialists after the Europeans, but talking about what we must do for the Global South without involving them, I mean, what about their self-determination? What about their ability to choose for themselves? What about their ability to work their way, create their own wealth?
I don't see how this is contradictory with what I'm saying. I don't see how.
Well, you said all these things we were going to do for them, or money we're going to, it just sounded horribly paternalistic.
No, it's not. I mean, we can have a longer conversation about that, but I don't think why it's contradictory with what I'm saying about cutting the GHG emission on the northern country, which is actually 100 times more than what they emit themselves. So they have a lot. They can, if we cut a lot, they can emit more. That's at the international level. That's how the balance is organized, and that's how the COP is discussing the different level of cutting emission we have to do in the north compared to the other countries. I don't see how paternalistic it is.
So that's a very interesting debate, and maybe we can take it also offline, outside afterwards. Leo, we count on you. Indeed, because, I mean, as you said, Laurence, as well, these are the countries which are most suffering as well from the climate. They're not only the ones who should use the energy and who want to develop, but it's unfortunately the same countries who are suffering the first ones from the climate events. We're touching almost to an end, and nevertheless, I want a message of hope, you know, and that's why. So can I ask you, in a very short sentence, every one of you, to give a message of hope to this next generation? Who wants to start? Hilde, can you start?
Well, that's a tough one, but I do think, you know, we have no choice but to try and figure out, and this is really a triple challenge. It's climate, it's nature, and it's inequality, that, as was mentioned. So we need to handle all of this at once, and I think avoiding polarization, but actually working together, collaboration will be the key word.
Yeah. Collaboration, international partnerships. Yes, go ahead.
Yes,
Jean-François.
I am not really optimistic. But if you want...
I oblige you to give a message of hope to the next generation.
Yes,
come on.
I may say that at this moment, as far as the water sector is concerned, we have all the tools we need to go ahead. We have to implement it.
Okay.
It's possible.
It's possible.
So, like an advertising say, just do it.
Just do it. Just do it. This is the message of hope, and we have all the tools necessary. Thomas.
Well, the sentence not for me, but I really support that. I think that space will not save the planet, but the planet will not be saved without space. So I think we definitely should reflect on that and make sure that space is the right tool and a sustainable tool in itself to save the planet.
Yes, space business as a sustainable tool. Thank you.
I will join Hilde for collaboration. I think international collaboration is really important, and we have already demonstrated that it is possible. We have chosen and we have managed to reduce the hole due to
the ozone hole. Huh?
Ozone hole, yes. Thank you. We have managed to do that at a global scale. So I think we are able to do that for climate change.
So we have the tools as well, as Jean-François said. Laurence, please be positive.
I'm very positive. I mean, I'm working really every day to try to make it work. So I'm really positive, and I think I witness every day people coming to me, at least in our company, but even in the other industry, a lot of people coming to me saying, "What can I do? What can I do?" Just like Thomas was saying, every day I've got people saying, "In my daily work, what can I do?" And I think with this. Well, there's certainly hope.
There are things to do then. Thank you so much. A round of applause for my panelists. Thank you.
Thank you very much, Maria Gabriela, and
Thank
to
you,
all
Christian.
the speakers for this very, very insightful and
dynamic, I would
dynamic, realistic. I mean, I like the term of climate optimists, climate realists. I think we have all climate realists here. Thank you very much. May I ask you to line up for a group picture of this panel, please?
Shall we go?
In front, yes. Ja, das auch. against the extreme climatic events. It is my great pleasure to welcome on stage the moderator and the organizer of this session, Dr. Bruce Chesley, who is our former IAF Vice President, and he is now currently Senior Associate at Teaching Science and Technology Incorporated, right?
Right, very good.
Bruce,
thank
the
you,
floor is
Christian.
yours.
Wonderful, thank you. Thanks, everyone. It's a pleasure to be here with you and moderating this very prestigious panel on this very important topic as well. We'll talk a little bit more about this, but the motivation and the inspiration really for this topic came about last year at the IAC in the aftermath of the tragic flooding in Pakistan, and thinking about just what Christian just said. We have all of these exquisite space capabilities, and yet we had upwards of 33 million people displaced in Pakistan during that flooding event. And so what more can be done to bridge the gap to those vulnerable communities, and how can we work together to do that? And obviously it takes everyone, it takes all of us to make that change happen. And in terms of social change and large-scale innovation, there are some models, a quadruple helix model, or some even say a quintuple helix model of social change and innovation. And really that's just a fancy way of saying what we already know, I think, is we need government agencies, we need academia, we need industry, we need policy, we need civil society to engage cooperatively in ways to make that change. And so as we assembled this panel, we tried to have perspectives from each of those points of view to address what is it that we can do better as a community to help climatically vulnerable populations around the world. So with that, I'd like to bring the other panelists up here and get them started. So first, our first panelist is Professor Grzegorz Rącza, the president of the Polish Space Agency. It's a pleasure to have you here. Obviously, you're representing a point of view of a government agency, and certainly as a government agency, you have a responsibility to the citizens of Poland and the civil society, as well as the broader community as part of ESA and the European community, and of course the world. So welcome to the panel. Next, I'd like to welcome Dr. Magdalena Gutowska. She is a, welcome.
Thank you.
Senior researcher at the Politecnico di Torino in Turin, Italy, and she is responsible for the Sustainable Transition Initiative at the Politecnico. So hopefully she'll say more about that. And the great thing about having Magdalena on the panel is she comes to us from a ocean science background, and so having that depth of understanding of the environmental science view, in addition to sort of speaking at large for academia overall. And then the final panelist we have with us is Sebastian Tailade, who is from OHB, from industry, and he, welcome. He's the domain manager for Earth observation at OHB, and so he'll speak to us about industry's perspective as part of that. There's one member of the panel that's not here today that I want to acknowledge. His name is Mahad Nair. He's from Pakistan. He was unable to travel here, but he's a really impressive young professional, an expert in astrodynamics. And it was the conversation that he and I were having last year in September in Paris that really sparked the motivation for this panel. So thanks to Mahad for his efforts, and unfortunately he can't be here, but just thinking about the impact of the flooding in Pakistan last year, it's widely reported that a third of the country really was flooded to some extent underwater. The thing that's less widely reported is nearly 33 million people were displaced during that event, and nearly 1 million homes were lost. And that got me thinking about the scale of that kind of disaster. And I sort of started thinking, okay, well, what kind of impact would that have on a city like Oslo? Oslo is nowhere near big enough. Oslo has maybe 400,000 residents, and maybe double that if you count the surrounding areas. And even all of Scandinavia doesn't have 33 million people, depending on what your definition of Scandinavia is, I guess. But yeah, I mean, you have to look someplace like Poland, has about 38 million people. So imagine the entire country, the entire population of Poland being displaced by a climate event. And of course, these climatic events are becoming more common and more severe, and so the need for action is really driven out by that, and the importance, so who are climatically vulnerable populations? Really, that's everybody. There's the ongoing flooding in Italy. There was the atmospheric rivers in California and the west coast of the United States earlier this year that contributed to extreme flooding, and the list goes on and on and on. And flooding is just one of many climate threats. So to kick us off, I'll turn to you, Professor Rancha, and ask for your perspectives on some of the initiatives that are going on both within the borders of Poland as well as your purview as part of the broader European community and contributing to these global questions.
Thank you very much, and I hope it will be easier to introduce the topic showing some presentations. You know, during this conference we have heard a lot that there is many wonderful data from satellites about the climate, about long-term trends, about the short-term phenomena. But the problem is that the end users, I mean local communities, local authorities, they do not use this data very often, either because they don't know that the data exists, they have no tools to convert the data to the information which is needed for them. So we have a gap, and we are talking a lot during this conference about filling the gap, about taking concrete actions. And indeed, I attended a technical session on mitigation of the effects of climate change. And all the 10 presentations or so were about observations. Nobody even mentioned end users. So we definitely have a gap, and we need to fill it. So in my presentation, I would like to be very concrete and to discuss what we can do, what I can do personally with my agency, with my country, to bridge this gap. Because the climate was changing, is changing, and it will be changing. If we see on different scales, the changes were really very big, and they have an enormous impact on the life of the planet. So, of course, we should think about long-term plans, long-term activities, and so on, but we should not neglect the actions which are needed here and now to save lives, to save our properties, to save our forests, from the effects of the short-term disasters. And you can have illustrations of just a few on this slide. So in the European Commission, there are structures dealing with those kind of disasters, with the crises. And on this diagram, you can see that a number of directorates, number of institutions of European commissions are involved. But I would like to draw your attention especially to the activities of the Joint Research Center. Because Joint Research Center helps European Union countries through the research in crisis management technologies, in the satellite image processing, analysis, disaster risk management, internet surveillance system, and so on. And they focus on integrated systems for risk analysis, for situational awareness, for early warning, for collaborative decision-making, everything which is really needed by the end users. So just to give you a few examples of their activity, they run global disaster alert and coordination system. So this is automatic geoinformation system based impact analysis, and it's about earthquakes, about cyclones, about tsunamis, droughts, flood, and volcanoes as well. We haven't mentioned volcanoes yet. This is very, very useful tool, and I encourage you to have a look and to use it. Another two examples are two services, one for droughts, another one for flood, also run by the Joint Research Center. So what we are going to do in Poland with this respect, we are thinking just about converting the data to the information, right? Because nobody needs satellite images except for New Year calendars, right? They're wonderful. But we need the information to make actions, especially during those disasters phenomena, during the crisis, different kind of crises. So what we are going to do, we are going to build a national satellite information system which will collect data from all possible sources. Copernicus satellite, our future national satellites, commercial satellites. We will provide data storage, but also archive. Archive is very important for the climate change studies. And then we provide also some computing power and some storage for pre-processed data. Then we will give an interfaces, API or whatever, to the companies, universities, so they can place their own applications, products, services on the system available for the end users. We already prototype several services like that, several maps like that, and indeed we see a big interest in Poland. And the very important point of this idea is that we do not create a closed service. We rather create an environment when many companies, startup, students, whoever, scientists, they can contribute if they have an idea how to support end users in some practical actions, they can put something here. Just to mention an interesting example, maybe not so much related to the climate, but very interesting one is that one of the company in Poland is preparing an applications which will guide you to a free parking places in the city based on the satellite data. You see, so exactly for us citizens, okay? But there are many others. There are companies serving big agriculture with all the information about droughts, about possible floods, about the state of the plants, about the need to make some actions to prevent some damage and so on and so forth. So we are already prototyping this system, and we hope that in the next couple of years it will be fully operational. But as I said, it will be growing and growing and growing, we believe. Now, on the level of the European Space Agency, Director General announced an idea of free so-called accelerators. That means actions which are beyond everyday actions of the European Space Agency. One is dedicated to understanding climate, but I would like to draw your attention to the second one, which is a rapid and resilient crisis response. We would like to participate in this, and I would like to outline the way we are going to participate. We propose to build a dedicated center. I mean building, personnel, because we believe that just networking is not enough here. Why do we need a dedicated center? Because we need to combine crisis management and high-tech expertise, which is quite different, and provide some operational capability, and this is the keyword, operational capability, because we need to support technology providers in final phases of solution development. We need to facilitate adoption of innovative solutions through demonstration and pilot activities in the field. And we have to provide operational support for early adopters among the crisis management entities, I mean local authorities, civil forces, and so on and so forth. So we have an experience, 60 years experience with similar activities, and from this experience, we have derived 3 basic objectives. The first one is that it should be demand-driven, focused on the end users. We have to talk to local authorities. We have to talk to firefighters, police, whoever is the custom officers, whoever is dealing with the crisis. What are their needs? What do they need if you go to the field? What are their needs to take actions, to take decisions? That's the basic thing. we should identify leading end users, those who are more familiar with modern technologies, who are eager to test new technologies, and to work with them very closely. The second objective is, we mentioned here again and again, bridging the gap. In this case, we should bridge the gap between the technologies, we have a lot of technologies, and the operational use. Through the whole chain, I mean technical capability development, through assessment and evaluation, then pre-operation utilization to full introduction. So I believe that, for example, in ESA, we should make a kind of a survey. What kind of technologies are available? And within ESA, I mean in-house and within the institutions cooperating with ESA, industry, universities, and having this survey, then we have to take those technologies and trying to make from the technologies useful tools, procedures, which could be useful for the end users. And then, of course, we should work beyond the crisis response. This is the first objective. I mean, again, the full chain before the crisis, risk assessment, prevention, response, long-term recovery. So why in Poland? Well, we are the border country of the European Union, and we are subject to many crises. We have experience in the crisis management. We have local forces which are open to innovative solutions. And in fact, we already play a leading role in several international activities. We have already a crisis information center run by Center of Space Research, Polish Academy of Sciences, using satellite data. And we have 2 cities which are experienced in this type of crises. On the pictures, you can see some exercises or real crisis actions when the satellite data are distributed to the end users. And we have this well-established culture of experimenting with innovation for crisis management. We run regularly some kind of crisis exercises. Also, we have civil protection models which are very active. They went to several countries recently, to Italy, to help in the case of the crisis. We are also European leader in implementing drone traffic management, which should be including together with the satellite data. We also have regional support in some regions of the country which are more exposed to the problems, and at the same time they have the good culture, the good structures already to experiment with those. So to summarize, we should not dream that we have power to fix the climate. I mean, controlling the climate is still science fiction and more fiction than the science. Understanding the climate is still science fiction, but more science than fiction, fortunately. But what we are trying to do with reducing emission and so on, we just hope not to disturb too much the climate, right? But we cannot really control it. Therefore, disasters will happen, and we have to be prepared for them. Full chain, again, risk assessment, prevention, response, long-term recovery. So the global effort is needed. Every country should contribute, and Joint Research Center and European Space Agency can help to develop and integrate. So I've tried to be very concrete, and to be even more concrete, I would like to invite you to check what I've said yourself and to come to Poland, especially in 2026, because we bid for International Astronautical Congress in Poland. You can find some information at the reception desk. You're welcome to check what I said.
Very good, thank you. Yeah, hopefully we'll all be there in Poland in 2026. Yeah, and clearly there's a lot there for us to peel back. A lot of great initiatives at the national, at the regional level, and the global level, indeed, as well as how to incentivize all of the other stakeholders outside of government, whether it's academia or industry or civil society. So thanks for that great introduction. I would encourage you all to send in your questions. So this is the reminder to send your questions in through the Slido app, and they'll pop up here on this tablet so we can ask your questions later. And yeah, so with that introduction, Magdalena, over to you. Why don't you say a few words about what you're doing at the Polytechnico and what role that academic and research institutions can play in this broader need to fill the gap and to drive action, really back to our theme of action.
Yes. I think it's important to think about vulnerable communities, not only, like you were saying, existing in developed countries, and of course Europe has been touched recently by many crises and has had many vulnerable situations. However, if we think of it globally, there are particular challenges that universities can help address to reach the really truly marginalized and vulnerable communities of the world. And I think there is a general consensus amongst universities when we think about the role of universities in addressing climate change is to go beyond those initial efforts that have been going on a decade or more that were very valuable and now set the basis that universities can stand on addressing their own sustainability, becoming models in this sense. But now to reach beyond that and to really say, how can we look strategically at what the research that our universities are doing, and how can we connect with local regional authorities to really address the needs they have, and even for some universities at the level of national or, for example, the European Commission. And the initiative that's happening at the Politecnico di Torino right now is exactly in that vein, where we think about sustainable transitions that our society is undergoing right now. So we have everything from energy to food to housing, all elements where our societies in developing and in developed countries are very rapidly changing and need to be addressed. Universities, through their mission, obviously have the goal of not only creating and disseminating knowledge, but also the mission of really innovating in education. We have that amazing contact with the youngest generation of people that are going to be really leading and making change for the good actionable. And so I think universities are understanding the responsibility they have to not only have that sustainable campus, but to really be the leaders in educating in innovative ways and connecting to the full ecosystem with government, with industry, to enable as rapid of adaptation as is possible.
Great, thank you. I hope we can explore that a little bit more, kind of that blend between the top down and the bottom up, connecting to these broader themes that come from European Commission or UN mandates, and the bottom up. How do we start with a green campus and a new generation of people and drive those two together? So yeah, great, thank you. All right, and Sebastian, of course, industry has a key role in all of this. There's really no space program without some industrial participation or some input. So what's the role of industry, and maybe what are some of the things that OHB is doing to help bridge the gap within that structure?
Yeah, so just to remind a bit the role of industry. In fact, it's an whole ecosystem, and it was very well presented, I think, in your presentation. In fact, we have a lot today already, and we have to use it mutually, so all actors that can play a role to support. There is already, or there have been 4 years already, so this International Charter, so that is used, especially in case of emergency, to react to support countries with data which is made available, coming from space, coming from any other sources. What would be, for me, really the next step to bridge the gap is what you mentioned also, is prevention. So how can we, so before reacting, how can we prepare the different, the vulnerable societies to react in case of disaster. And here, so we have really, especially with Europe, a wonderful tool which is Copernicus, so which is really providing a huge amount of data, and that is also going to improve now, especially with the new missions that are currently in development, so the missions for CO2 monitoring, missions for land surface temperature, etc. So that really bring an added value that can really be brought, especially with a topic on effects made by climate change. So here, well, not OHB, in fact, the industry in general, and really so can really allow to implement, let's say, the tools and the services at the end that are really needed for the end users. And this going together hand in hand with universities also that will define new algorithms, let's say, or new products, so that can really help scientifically at the end, so the different populations to prepare so for prevention, really. Yeah. And this is where industry, together with agencies, of course, and also institutional partners that will have also to find, I think, really internationally, or to put money on the table also to implement this, because at the end, prevention, I'm pretty sure, can be much cheaper than reaction afterwards. Yeah? And here, because we always talk about billions of dollars, yeah? So when there are floods or droughts, etc. Yeah? And if we can prevent, we can certainly improve this a lot. And, but this is, of course, the financial aspect. The most relevant aspect is the societal aspect, because then we can really support people, help people. Yeah? And this is, therefore, a goal that we can really do all together with institutions, national, maybe the national, the organization of the UNO, United Nations. Thank you. And together then with different nations, different space agencies, universities, and industry to implement. Yeah. So yes, OHB in that role is also participating in developing the systems and also providing the space part mostly, so the space components, be it in space, be it underground, and providing the data and the services to the customers, or to the users at the end. But it's really a part of the whole, and I think we have all in our hands to make it happen, and this is now what has to be really done in the coming decade. Probably we can do a lot with also the increasing Copernicus program, the international cooperation with other agencies, be it from the US, be it from Asia. Yeah? And this is what I believe can really bridge the gap.
Great. Thank you. Yeah. So I think there's a clear alignment of values and goals across the different sectors, across the different areas, and so certainly, yeah, we can all agree having government-driven programs that identify the needs to help the vulnerable populations, providing data sets and open source access to some of those foundational tools and historical records and archival data, and so on. But maybe, if I may, just to try and drive a little bit of controversy in here, let me pull on the incentive structure a little bit. So clearly, a government agency is beholden to the taxpayers, to the citizenry. That's where the euros come from. That's where the money comes from. Universities have many constituents, but mainly it is that next generation. How do we educate the youth of tomorrow to be leaders for the future? And industry has financial stakeholders that they're accountable to, and so if just to oversimplify the situation, if OHB is going to build a satellite and the Polish Space Agency is going to give the data away for free, how does that work? And how do we keep universities driving at the forefront of the most pressing needs of society, and not just whatever the whims of their constituents are? So maybe say a little bit more about what we can do to help bridge the gap, maybe in incentives and what's driving those behaviors. So do you want to start us off on that?
Thank you. Well, we are in the new space era, so the roles of the space agencies has changed. I mean, we are no longer responsible, especially in emerging space countries, we are no longer responsible for big missions. Of course, we participate in big exploratory missions through the international participation, and this is very important for developing new technologies, which then can be used in our everyday life. but the center of gravity is moving towards the use of the space, practical use of the space. And our role is now being an integrator. So we have to work with scientists to see what are the possibilities, what are the new opportunities. We have to work with other governmental agencies, with the society, to see what are the needs of the country, what are the needs of the society. And then we have to work with the industry, so to encourage them to use what science is proposing to fulfill the needs, what government, what administration, what citizens needs. So this is essentially a new role of space agencies, and we are trying to fulfill this role.
Great, thank you. Yeah, so Sebastian, what sort of motivation, and direction from a government agency would be helpful to spur that kind of response to the priorities of a national agency, say?
So I believe, in fact, the problem cannot really be solved also at government agencies. So for me, it is really a problem that is international. This is what, in fact, I wanted to say before. It is really a topic that must be tackled by the United Nations. Because for this, there must be agreements, so to put money on the table, because everything has a cost, definitely. I said, I'm convinced that the cost is much lower to implement such prevention steps rather than reacting afterwards. This is, I think, what needs to be understood, and what should motivate this, let's say, shareholders at the end, so that would be able to fund the gap, yeah. And so this is why, for me, the national agencies, of course, will then play a role, because the implementation of this program, let's say, that could be generated would have to be done through the countries and through the industry at the end of the day, yeah? And then, so as soon as there is a potential international support, then I'm pretty sure that then everything can be done, let's say, in a good way. So what is a possibility, of course, maybe to simplify the things, is to think about mutualizing pieces of a global solution. That could be a system at the end solution. And I've said before, we have in Europe a wonderful tool, which is Copernicus. Yeah? In the US, they also have Landsat and others, so they were building the SBG. So also very strong systems that can really support at the end and bring more data and more often data. And I think at the end here, this is where the mutualization can be done, organized between the space agencies of the world, yeah, the national agencies and ESA and intergovernmental agencies. And about implementing, then it is not the problem. So we have the tools, we have the know-how, in Europe especially, we know. So we have very mutualized countries through the European Space Agency, through programs like Copernicus with the European Commission, and so everything is there. We must just put it and move.
Great, thank you. Yeah, putting those incentives, removing the barriers to movement, I think that's the thing, because the vision is clear. Very good. So, Magdalena, bring us home here. In terms of the science community, science and the exploration of knowledge for knowledge's sake doesn't always respond well to directions, say, go study this. So how can we achieve a balance there?
Yeah, I would look at it from the context of institutions of higher learning and what are the incentives that are driving them. And I see it as, in a way, quite straightforward. We have the students asking for new directions of study, and they're very loud, they're very clear, and you can see new degree tracks rapidly developing in universities across the world. There's a lot of innovation happening there. You have the local and regional communities and administrative bodies faced by more and more crisis, reaching out to those institutions saying, we need help. And that is a major incentive for those institutions to maintain their credibility and their status to be reactive in a genuine and helpful way. And then finally, going back to what you were saying about there being a role, obviously, for the UN, for larger institutions and funding bodies for driving the research programs and the allocations of funding towards certain research directions. And of course, that's going to be a major driver that motivates universities to steer in a different directions. And you see that happening.
Yeah, those partnerships are very, very important, and yeah, you do see them happening. And I wanted to tie back to what Sebastian said about kind of expanding beyond company-specific objectives and university-specific objectives, even national perspectives. I'll just throw it open to any of you to see, what other things could be done to help broaden the international cooperation and collaboration, specifically in this thread of getting usable data, actionable information, as you said, Professor Rancha, to the end users, to the people who have to decide, am I going to evacuate because of a coming flood? To your point of getting out in front of the next crisis. So any thoughts of what we can do to further broaden the participation in these initiatives?
Well, I think, of course, that there must be an impulse that is given. So we see there are, there was also last week also the G7, etc., where really countries are exchanging on big matters. There was so there is really now often this COP that takes place every few years, where really we see the motivation of people to do something. So of the people of governments, so to do something jointly. So I think the ingredients are there. Of course, the difficulties are often, at the end of the day, economic, especially in the conditions today after the COVID situation, and also still of the geopolitical situation, which is always a bit tricky between especially major actors. But here, everybody and all countries are concerned. Vulnerable countries, but also major countries, not the US, for instance, so in first place, And so therefore, there should be really this motivation to act together, because even if we are sometimes fighting on some topics, however, we are still all together on the same planet. And here, this is where there must really be this understanding, so to react together, go beyond also the conflicts that we may have, at least on this topic. I know it may be utopic, and this is maybe the difficulty here that we have to face, that people, it's very hard to make this move. But for me, it can only be the only starting point. Because if it is not jointly, if it's not made jointly, of course, this would have certainly some consequences also on maybe, so there is no reason that one government, one Europe, whatever, brings a lot of money on the table that profits to all the others, and that the others do not move. This would not be fair. And this is, I think, the difficulty, the hope that I personally have. So as a European citizen, where I grew up really in a growing Europe, and really where the countries are really federating themselves, putting things together, and so this is my hope, so to go beyond this, really, so to find a way. And as said, if the mechanism is unblocked, then everything would follow. We have everything ready for that. This would be my answer.
That's great. Yeah, and certainly there's a lot of emphasis these days on ESG, on environmentally and sustainable growth targets for companies, and corporate social responsibility, and certainly the responsibility of companies goes well beyond simply the financial stakeholders and to society writ large. Yeah. Any other thoughts relative to how do we further globalize the participation in these initiatives?
I believe that what is very important is sharing the experience, sharing the ideas we have, because in every country we have some brilliant ideas, some modern, novel solutions. So sharing this experience, I mean, it will create a real added value. Just to give an example, last week I participated in ESA security conference, and again there we discussed how to use the satellites, I mean, to serve citizens for security of their life, okay? And I have learned a very interesting thing from the representative of African Union. He said, look, everyone understands three colors, red, green, and blue. And just today, I have realized, before giving the presentation, I've got remote control, okay, with no instruction. And nobody instructed me how to use it, okay? But it has 3 buttons. Red is back, green is next, and blue is the laser. That's enough, okay? So what he said is that they deliver applications for the fishers with just, 3 colors. If it is green, you can go fishing. If it is red, be careful, go home. If it is red, stay at home, because there might be a danger. And just with this simple applications, they reduce very significantly a number of deaths because of storms in the sea. Excellent example. And if we share this kind of examples between us, I think this will be a real added value.
Yeah, so often that's the problem that we have as engineers and scientists, is we understand all the intricacies and complications, and we feel like we need to explain all of that instead of synthesizing. Yeah, very
like
good.
This.
Like that, very good. All right.
To your points of globalization and sharing, when we talk about the vulnerable communities, we're talking about the nexus of socio ecosystems that are vulnerable. So we need the humanities, we need the social sciences, we need the strict sciences, the physical sciences, the environmental sciences. Universities have, depending on their charter and whether they're engineering universities or full universities, really can bring in a full scope of academic knowledge into informing and helping in those systems. An important step forward is globally having the development and the deployment of adaptation plans. Universities, because of that unique subset of knowledge they have purview to, can really contribute to them. How do we share them effectively? How do we not have people reinventing the wheel? Universities, some of these networks that are around climate change, adaptation, mitigation that universities are a part of are over a decade old. Many are younger. But they're not interconnected. As usual, there's an underrepresentation of the global south, and yet there are those networks as well. And something positive that I want to end on in a concrete example, at COP27, led by the UK network of universities for climate change, there's the call for university networks dealing with these topics to come together, to have a network of networks to represent themselves better, not only at the COPs, but to really progress effective sharing. And so watch that space at COP28. I think it's an important place where universities can do a better job of their role in this topic.
Great, thanks. We had a question from the audience that I think follows on nicely with that. As you mentioned, there's been decades of research in oceanography and climate science and pollution and carbon monitoring and all of that. And the question is, okay, so it's been decades since we've had data about the climate crisis. And the question is, do you think the current effects of climate change will be enough to start real action? So maybe start with the academic perspective, and I'll invite the others to comment as well.
If you take it down to the human element, when you think of the increasing number of people that are suffering very acutely on the planet in response to climate disasters, I think, of course, that inspires action, inspires change, especially in the younger generation who has that open and broader horizon that's open to new technologies, new information, new educational forms, and also that strong motivation that I can help, right? And so I think, that's going to be a major driver for really pushing action forward.
Great, thanks. Yeah, so what, anything from your perspective and a government agency of what can we do, given everything that we know and all the historical data, how does that spur us to further action?
Well, I think that we need somehow to convince society and convince decision makers that, all disasters which are happening day to day, they should not be handled case by case, but but we need some systematic action in this whole chain. I mean, risk assessment, prevention, and so on and so forth, to prepare those tools I have mentioned before the disasters will happen. I mean, in Poland, fortunately, we do not have big earthquakes. We do not have tsunami on Baltic Sea, fortunately. Okay, so there are no big countrywide disasters. There are some floods, okay, quite often, but there are many local things, local floods, local fire forests, local, you know, little earthquakes because there was a mine under the city, okay, and the ground went down. So instead of dealing with every such a case independently, I mean, we should have a systematic actions. And I have given you examples of what we do from the Polish Space Agency, but I believe that other agencies in the country and also internationally, we have to work together to be better prepared.
Great, thanks. Sebastian, anything to add on that relative to you know, real actions and change?
Yes. So regarding the questions, I can only also regret to see that we have to come to this point now. So we have seen over the past decades, so really massive waves of people having to migrate, so because of the conditions, etc., and because nothing is really being done or nothing can really being done. So in the countries themselves, vulnerable countries, often it is a matter, an economic matter. So it's very hard. Sometimes also other so social, political, corruption, etc. So that comes on top, yeah. And I find it very sad that so far nothing really happened from the leading countries. Yeah? So that could really have tools or put tools in place to react. And indeed now we see that in these bigger countries or more powerful countries in terms of economy, we see more and more societal developments with Friday for Future and all this let's say this philosophy that is really growing very quickly. Yeah? And so the question, I don't know if something can happen. I said, I really grew up with Europe and seeing this growth of mutualizing things. And so I'm really an optimistic on that sense and hope that something can be done. And I hope now we have reached the point that yes, something can happen. But as said, maybe it's a bit utopic. Huh?
Yeah, that's great. It is a big topic, and it's yeah, it's clear the values and the goals are aligned, and driving that action. It kind of gets back to a couple questions we have here that relate to incentives and what's the structural impediments or structural drivers that are enhancing the possibility for action. So maybe I'll start with you again, Sebastian. You know, one of the barriers that prevents action to happen can be lobbying and special interest groups. So a lot of competing voices and competing needs and competing interests. How do you think that might be tackled?
By lobbying.
Yeah, your opinion, of course.
No, of course, it is. Yeah, it is very important to lobby. We see also assets. Unfortunately, but we see more and more cases of emergencies, so be it societal, be it earthquake, be it whatever, yeah? Which the alarm is there, the alarm is already ringing, yeah? And this may be enough, so to really alert. It's clear that the problem is very difficult always because there are different lobbying directions that are given, that are taken, that are proposed to the key decision takers, yeah? And it is very often very hard for decision makers at the end to take the decision, yeah, because also we are based so it is a very complex because of course this has huge economic impacts, so if we set up this kind of help really and which is a very hard decision, and so I cannot really answer the question. I can only say yes, so everybody that can lobby in the direction with the political support that we can get, we must do it. This is something that we are strongly doing currently in Europe, for instance, for the Copernicus program, because we all know there are always some economic issues, so to implement the program. And this is one example, but this is, in that case, unfortunately, the lobbying the only thing we can do. And this is clear that there will be other lobbies that will lobby against. Yeah, but what else can we do?
Yeah. Great. Grzegorz, I'd be curious about your perspectives on that. Clearly, as a government agency, you bump up against the political sphere and all the different competing demands that go along with that.
Yeah, you know, there's always competition for the budget. I mean, not only for the space technologies, for any other technologies. And we always have this dilemma whether to finance, you know, solving immediate problems, everyday problems we have. I mean, big inflation, I mean, energy crisis, post-COVID recovery, war in Ukraine, and so on and so forth. In addition, some local problems in our cities or villages, and long-term investment. Okay, and it is quite difficult to convince decision makers, but we have to do that. You know, if we want to have prospects for a safe, secure life, for prosperity in the future, we have to invest today. We are discussing a lot about investing in this in new satellites. We have to invest in all those procedures, tools which are needed to protect citizens, long-term protection again, I mean. So. And I believe that the role of the conferences like this is very important precisely for this reason, that from this kind of conferences we can send a message to decision makers. Okay, you have those everyday problems, but you have to spend some money to avoid those problems in the future.
Great. Okay, I have one more question about incentives, and then I have a question about science. So. So yeah, the question from the audience here has to do with fire mitigation and the urban woodland interface areas, and that's you know, clearly a problem as populations grow and expand out into the interface with wildlife areas. And there's a location, the audience member mentions Colorado in the United States, where insurance rates are adjusted, you know, I guess increased if you're in a fire vulnerable area in a woodland area. You know, so what sorts of, clearly that's an intersection between a policy kind of thing and a business industrial kind of thing. Can you think of other areas where that kind of an approach might help drive action? Anybody? Okay.
Everything is a bit linked also with what we said before, because at the end there is always an economic reason not to move. Yeah? And so you mentioned insurance as an example. So yes, indeed. So this is becoming a massive problem, and it is also. So there is not also so there are other parameters, like currently the crisis that leads to hyperinflation, etc., that always then need a request for higher budgets at the end of the day, yeah, which is really becoming an issue. So the only thing that I can say, yeah, so is if we act quickly, of course, then it will cost less than if we wait longer. Also, in perspective of investment that has to be done. Yeah? So I cannot really. I think answering the question is very hard, but what I can only say is that with the consequence, we can see the consequences. Yeah?
Right. Yeah. Yeah, and finding those areas where we have knobs to turn, where we can implement those prevention kinds of measures and make those attractive. Yeah.
So I think we can, and we have to address this problem in two ways. One is from the government side to create a kind of environment which encourage and enable companies to make products and services which are needed to prevent crises and to help handling and mitigating crises. An example is the National Satellite Information System I have presented. But the other way is through some legal regulations, because we have to, somehow we have to forbid people to behave in a risky way. For example, the land next to the river is quite often very cheap because there is a danger of the flood there, okay? But still, some developers, they are building houses there. And then 10 years after, big flood, and there is a tragedy, right? So also on the governmental side is the responsibility of setting the law, setting regulations, so to forbid the people this kind of risky behavior.
Yeah, it's a web of regulations and policy and laws and financial incentives and business interests that have to combine to make all of this work.
Right.
Yeah, very good. Thank you. Okay, Magdalena, over to you. A non-controversial question here. Should the science community be more extreme in their activism relative to climate action? Would that help the situation?
I'm not a proponent of extreme activism. At the moment, what we need is integration of all sides. And science, by definition, science should be truth, and there's not a more extreme version of truth or a less extreme version of truth. So it's where I think that we all have a responsibility, regardless of whether we're coming from an industry, a government, or a university setting, is at this point talking about the risks and the projections of climate change and climate damages in a much more specific way, of not always erring on the side of caution and saying there's X% chance, but really just committing to saying there are people suffering around the planet, and more people will suffer soon. And just, in a way, taking ownership for what we know and expressing that. So that's the way that I would answer that question. It's not so much of extreme activism, but already with much more confidence and determination communicating what we know.
Great, thank you. Well, obviously there's much more that we could discuss about all these topics, but I see we're at time. So thank you for your insights and great discussions. I look forward to continuing the conversation. Clearly the values and goals are aligned, and I appreciate the perspectives from academia, from government, from industry to help figure out all the ways that we can work to bridge the gap. So let's please thank our panelists. Zhegov, Magdalena, Sebastian, thank you.
Thanks a lot.
Thank you, Christian.
Thanks a lot, Bruce, for organizing this, to bringing this important topic together and on stage here. I would like to ask you also to line up for a group photo over there, please. And thanks to the audience for being with us. We are breaking now for lunch, and we will reconvene at 13:50 sharp, so 10 to 2. Please be back. There is another interesting GNF coming up. And during lunchtime, there will be also the IP session going on in the foyer. So if you wish to join, please do so. Thank you.